A lot of students have watched this playlist, Signal and System Gate PYQs with tricks and techniques, and the branches covered were electrical, electronics and instrumentation. But this playlist is a sample playlist. Not all videos are covered here. If you need all videos, in that case you can download Shrenik Jain Study Simplified app. Visit the course Signal and System ECE Electrical Instrumentation Gate PYQ Solution. It's in English, and you can check the features here. You will get videos, notes, doubt solving group. Yes, a detailed solution plus tricks are present. You can download the videos and the PDF, and you can refer offline without the internet. And there are 3 validity plans: 6-month plan 300 rupees, 1-year plan 400, 2-year plan 500. Things are affordable. It's inclusive GST, so no extra cost. Now you can check the content section, and you can see syllabus here, course detail PDF and PYQ solution. So recent PYQ solution is also there. 2025 PYQ solution folder is here. And if you need the previous year's PYQ solution, in that case I have covered branch wise. Here also you will get the branch wise, you can see here. And if you check the electronics folder, in that case if you check the note section, 2024, 3, 2, 1, 20, 2019, 2018. So this much branches are covered. So these are the recent papers with tricks and techniques you will get. That's very important, because in GATE exam time is the important asset. So you have to save time, you have to use the fastest approach possible. Okay, other branches you will also get. So whichever branch you are writing the GATE exam, if you practice more and more PYQs, you will get the confidence. That's it for today. You can visit the course and do your practice. So that was a small update from my side. Thanks for watching the video. So in today's class, we are going to solve Signal and System previous year questions. These questions were asked in GATE Electrical 2024 paper. First of all, I will give you all the questions so that you can try by yourself, and then you look at my solutions with tricks and techniques. First question in front of a screen. Very easy question. Pause the video, try by yourself, then go to the next question. Again easy question. The topic is Laplace transform. Pause the video, try by yourself. There is no need to write anything. See, mark the answer. Now this is a moderate level question. Calculations are involved but not very tough. This is a tough question, so think on it. This is easy question, not that tough, moderate level calculation. This is a tough question. Now this is easy question, because similar questions we have done in the practice courses, previous year papers. Okay, so not that tough. And that's all. All these questions were asked in electrical paper. Now let us see the solutions one by one. Very first question. Suppose signal y of t is obtained by the time reversal of signal x of t. That is, y of t is equal to x of minus t, where t is going from minus infinity to plus infinity. Which one of the following option is always true for the convolution of x of t and y of t? A, B, C or D? Correct answer is option A. You know why? Because they are saying you have to comment on what? Convolution of x of t and y of t. See carefully. We have to comment on a signal, let us say z of t, which is what? X of t convolved with y of t. But what was y of t as per the question? Y of t is nothing but x of minus t. So this is your z of t. If I replace t with minus t, what will happen? In that case, z of minus t would be equal to x of minus t convolved with x of minus t, right? Where t you have replaced with minus t, this is what you are going to get as the calculation. So if I simplify it, can I say z of minus t is nothing but x of minus t convolved with x of t? And in convolution, a convolved with b, b convolved with a, both are same to same. Therefore, can I say this is nothing but x of t convolved with x of minus t? Just taking this here and this player here. If yes, then this thing is what? This thing is z of t. If that thing is z of t, therefore the conclusion is z of minus t is equal to z of t. This implies the given signal is what? This is even signal. So even signal is the answer, and hence you can see that option A is correct. Okay. Now this is method 1 to solve a question. There are multiple ways to solve the question. This is one of the method, and I was like, the question is very easy. See this line itself, I knew the answer. By seeing this line, I knew the answer. You know why? Because x of t convolved with x of minus t. This is what? This is autocorrelation function. So if this is autocorrelation, what is the property of autocorrelation signals? That signals are always even. Okay, they are always even. And because it was autocorrelation, we know the property, it is even. So see the option, mark option A, and that's all. The correct answer is option A. No need to do all the calculation. Okay, so that was your method 2. Now let us go to the next question. If u of t is the unit step function, then the region of convergence ROC of the Laplace transform of the signal is what? A, B, C or T. The correct answer is option A. You know why? Because looking at the signal, what do you get the feeling? Is it a finite or infinite signal? Sarji, it works in this range. Okay, so this u of t minus 1 minus of u of t minus 10 will give us a finite signal, right? This calculation gives us the idea that x of t would be what? It would be a finite signal. If it is a finite duration signal, in that case ROC is entire S plane. So ROC will be entire is or will be. Okay, so ROC will be entire S plane. So therefore the correct answer is RE of S is greater than minus infinity and less than infinity, because the given signal was a finite duration signal. Understood? Very basic concept, very basic question. Let us move forward for the next question. Let x of omega be the ft of the signal, which is Fourier transform, and signal is given like this. The value of derivative of x of omega at omega is 0 is dash, rounded off to 1 decimal place. So the correct answer is what? Let us see step by step. So the very first step is, given signal is what? X of t, which is equal to e to the power minus t to the power 4 cos t. And you should know, in the Fourier transform, x of t, if I take Fourier transform of that, it becomes capital X of omega. If I multiply with the t, what happens in the Fourier transform differentiation? So j into dx by d omega. This is what it happens, right? Now they need what? They need derivative of x at omega is 0. So derivative of x, this player they need. So if they need that player, let us divide by j on both the side. If I divide by j on both the side, therefore can I say that dx by d omega is nothing but what? It is nothing but t x of t divided by j. This is what our dx by d omega looks like. Now if you see carefully, it gives you a feeling, this is a time domain signal, which is f of t, right? And this is Fourier transform signal, which is what? Which is capital X of omega. If this is the time, then respective Fourier transform is capital X of omega, correct? So if that is the case, looking at this expression, can I say, as per the question, they needed dx by d omega at omega equal to 0. What we needed? Dx by d omega at omega equal to 0. So as per our notation, it is what? Capital F of omega, where omega is 0, and this is what? This is nothing but area under curve. Area under which curve? Area under f of t. So that is nothing but integral minus infinity to infinity f of t dt. So that is what now. Let us do the calculation in the further slide. Oops, we do not have any further slide, so I have to do cut paste to get the answer. Now see carefully, this is what we are going to solve, where f of t is this thing, right? So do the substitution. This is our answer, right? This is our answer. If we do the substitution, it is integral minus infinity to infinity, and then we have what? We have t by j x of t dt. And what was our x of t? So integral minus infinity to infinity t by j, and then x of t was e to the power minus t to the power 4 cos t dt. If you see carefully, we can use the property of integration to solve this question. So definite integral property says whenever you have minus a to a as the limit, check your function whether it is even or odd. If the function is odd, integration is 0. If the function is even, then 2 times integral 0 to a f of t dt. This is how you solve. So I was like, okay, let us check this function whether this is even or odd. So if t replaced with minus t, this is minus t. Here if t replaced with minus t, same term as it is. If here t replaced with minus t, so cos of minus t is cos t only. So if you see carefully, then this was your original function, and if t is replaced with minus t, this is what you are going to get, a minus outside. This means your function is odd. Whenever f of minus t becomes equal to minus f of t, which happened here, right? So when we replace t with minus t, we are in search of f of minus t. This is what we got, which is nothing but minus f of t kind of format, right? So here the given signal was odd signal. So if the given signal is odd signal, this is how you see verbally, this is odd, therefore the integration answer is 0. Understood why the integration answer is 0? Let us go to the next question. The input x of t and the output y of t of a system are related as like this, then a, b, c or d. A tough question, right? Because linear, non-linear, causal, non-causal, we have to check a lot of things. So the correct answer is option B. Let us see why. So starting with the linear, non-linear solution. Step number 1, to check whether linear or non-linear, if the input is x1, the respective output is y1, and the things would look like e to the power minus t integral minus infinity to t, then we have e to the power tau x1 of tau d tau, correct? If the input is x2, then the output is y2, and same to same copy you have to do, okay? Same to same copy. Instead of x1 of tau, it would be what? It would be x2 of tau. That's it, okay? It would be x2 of tau. Now if my input is x1, okay, first let me write my general y dash term. Y dash term is what? Y1 plus y2. Then I will compare with the y double dash. So y dash is not the derivative of y, it's just the notation that y dash is our addition of y1 plus y2, right? So if that is the case, if I add them, e to the power minus t is outside, integral minus infinity to t, e to the power tau x1 of tau d tau is added with integral minus infinity to t, e to the power tau x2 of tau d tau. This is what the things are going to look like, right? Now if my input is x1 plus x2, then in that case what is my y double dash? So in that case, Sarji, e to the power minus t integral minus infinity to t, then e to the power tau, input is now x1 of tau plus x2 of tau, and then this is d tau. So smart students can conclude here only, seeing y dash of t and then y double dash of t, both of them are same. This is how smart student knew it. But if you are not that smart, then you have to do one more step, that is splitting of integration. This thing can be said as integral will go to this function and then integral will go to that function, right? So e to the power minus t outside, integral minus infinity to t. Okay, let me write in the same format. This is how the things would look like, okay? If you do the expansion, this is how the things would look like. Check it out. Are you getting the point? This thing multiplied with here and then multiplied with here, so e to the power minus t would be for both, then integral for him, you can see integration 2 times, and you can say that yes Sarji, that y double dash and y dash, they are same to same. Therefore whenever y dash and y double dash are same to same, we have seen in the practice course earlier also, then the systems are linear system. Okay, this is how I have proven the system is a linear system. So option A is wrong, and then B, C, if I check time variant invariant, I can get the idea whether B or C is correct, or if both of them is wrong, then D would be correct. That's how the things would look like, right? So if I check now time variant or invariant, so for that we have delay and replace logic, again solved in the practice course already, that this is my technique to solve this kind of questions. First I will do replace, that wherever t is there, replace with t minus t naught. Okay, so replacement if I do, then my y1 becomes what, e to the power minus t, which is changed as t minus t naught, and then integral minus infinity to t, where t is changed as t minus t naught, because replacement means wherever t is there, replace with t minus t naught, then e to the power tau x of tau d tau. This is how my y1 looks like. Now do the delay. So delay happens to whom? Delay happens to input only. So in that case, so who is my input? So e to the power minus t is not my input, minus infinity to t is not my input, e to the power tau is not my input, x of tau was my input. So that would be delayed with a t naught. Okay, now both of them same or not? Some students will say, sir, they are not same. This means you have not checked properly. X of tau here it is not x of tau, so make them same. If I have to make this as x of tau, what should I do? So for that you have to replace tau minus t naught is k. Okay, so if I do that, differentiate on both the side, then d tau changes to what? dk. Also change the limits. Okay, so to change the limit, first see tau limits minus infinity and t, then see who is the new variable. K is the new variable. So if I place infinity instead of tau, minus infinity, the answer is minus infinity only. But if I place t, then k becomes t minus t naught. Okay, now change your y2 and see how the integration looks like. So y2 is equal to, first let me copy that so that you can see what things I am going to change. Wherever tau is present, it would be changed, right? See carefully. First of all, wherever tau is there, those pairs would be changed, and also integration limits would be changed, right? Therefore, I can say e to the power minus t is unchanged, limits are changed because k is going from minus infinity to t minus t naught, right? Then e to the power tau is what? If t minus t naught is k, then tau is k plus t naught. So k plus t naught. This is what the things are looking like. Now what's next? X of tau minus t naught is k and d tau is dk, right? I can split this pair, e to the power minus t, integral minus infinity, t minus t naught, right? And then I have e to the power k, e to the power t naught, x of k dk. Okay, what's next? Sarji, you can take this pair outside. Yes, because that is a constant. K are the variables, those cannot be taken outside. So if I take this pair outside, can I club the powers and can I say e to the power minus t naught, and then I have integral minus infinity to t minus t naught, then e to the power k x of k dk. This is how the things are looking like. So if I replace, check it out, now comes the integration property. See carefully, change of variable property, that if k limits are this thing, function is in terms of k and then it is dk, you can replace k with tau, still the integration would remain same. How come? You only check integral 0 to 1 x cube dx, is it equal to integral 0 to 1 tau cube t tau? If yes, then same property I have used. Okay, same property I have used, just change of variable property. So change of variable property will give me my y2 is equal to e to the power minus t naught, integral tau is going from minus infinity to t minus t naught, e to the power tau x of tau d tau. Then you will say, oh Sarji, this same thing is our y1 also, same to same. Check it out, same to same. If you got same to same, this is what then? y1 is equal to y2, means we are in a time invariant. They are not varying with a time, they are time invariant. This is our conclusion. So time invariant, and we had a linear system. This is our conclusion. So basically this is LTI system, linear time invariant system. So hence option B is correct. But this is method 1 to get the answer, and I know a lot of student will say, sir, this is a topper's question, very tough, see how much time it requires because all the calculation and stuff. Okay, so you might think in that way, but I do not think in that way, because I know that I can solve this question in one line because I have method 2. Our question was y of t is equal to integral minus infinity to t, e to the power minus t was outside. Okay, let me first copy, otherwise you will say क्या लिख रहे हो आप, हमको कुछ समझ नहीं आ रहा. Okay, so let me write as per the given data first, and then let me do my manipulation in the next slide. Okay, so if I take this player inside and I club the powers of exponential, this is what the things would look like. Minus is outside, t minus tau would be inside, x of tau and then d tau. Correct? If that is the case, don't you feel it gives us the feeling of what? Convolution between the two signal. Yes or no? The standard definition of convolution, that here this player gives us the idea. Let me write in this way. This exponential player gives us the idea about the h of t. Okay, so h of t is what? E to the power minus t u of t. E to the power minus t u of t. This player gives us the idea of what? X of t, input signal. So it's nothing but convolution between x of t and h of t. Okay, so if it is convolution, convolution happens in which system? Convolution is possible. Convolution is possible only in LTI systems. So this system was linear and time invariant system. So just by taking this player inside, clubbing the exponential power, looking at this stuff, it's x of t converted with h of t. So this is where I got the idea of x of t, and this is where I got the idea of the convolution, right? So it was e to the power minus t u of t, right? So in that way, convolution happens only in LTI system. The answer was LTI, linear and time invariant. Easy. So no need to do all these things. Just look at the question, mark the answer. If you know the tricks and techniques, let us move forward for the next question. Consider the DT system, discrete time system, T1 and T2 defined as follows. So you can see that which one of the following statement is true. This is what they are asking, Bibo stable concept. So in today's class, we are going to solve signal and system previous year questions. These questions were asked in GATE IN 2024 paper. First of all, I will give you all the questions so that you can try by yourself, and then you look at my solutions with tricks and techniques. First question in front of the screen from autocorrelation, easy question. Pause the video, try by yourself, and then go to the next question. Again, easy question from DTFT. Pause the video, try, go to the next question, direct formula based question from DFT, FFT, and then we have Nyquist concept, very simple question. Then this is also no brainer. Read the question, mark the answer, no need to do any calculation. Very easy, similar question we have solved in the 2024 paper earlier. And then this is also easy question from Laplace transform. Just you have to be aware with this ROC, otherwise you will fall in the trap. Now this is also easy question from DFT. So overall the paper was easy for signal and system section. Okay, zero tough question, zero moderate level question, zero out of syllabus question. All of the question were easy. Let us see the solution now. A discrete time sequence is given by x of n, which is equal to 1, 2, 3, 4. For n is greater than equal to 0, less than equal to 3. The zero lag autocorrelation value of x of n is what? A, B, C or D. The correct answer is option D. Why? Let us see. First of all, you have to understand what is zero lag autocorrelation value of x of n. This means value of x of n at n is equal to 0 after doing the autocorrelation. Understood? Okay, let us see now. First step, autocorrelation function is equal to x of n convolved with x of minus n. So autocorrelation concept is asked twice in 2024. It becomes important now. See carefully, x of n is equal to 1, 2, 3, 4, where the arrow is at the start. Therefore, x of minus n would be what? All this player will go to the left. It's the mirror, right? So 4, 3, 2, 1, and the arrow would be here, right? So if I do now my autocorrelation using table, it would look like this, where x of n values I am writing here and x of minus n values I am writing here. Okay, you can do vice versa also if you want. Answer remains same. So 1, 2, 3, 4, and then I have 4, 3, 2, 1. Now do the multiplication. At this position we have 1 and 4. So 1 into 4 is 4. For this position we have 1, 3. So 1 into 3 is 3. Then 2, then 1, then 8, then 6, then 4, then 2, then 12, 9, 6, 3. Then we have 16, 12, 8, 4. Now what's next? What's next? All the elements in this area should be added. So only 4 is there. All the elements in this area should be added. So 8 plus 3. In this we have 12 plus 6 plus 2, and then we have 16 plus 9 plus 4 plus 1, then we have 12 plus 6 plus 2, then we have 8 plus 3, and finally we have 4. Okay, therefore I will say my autocorrelation function has the value what? 4, then 8 plus 3, which is 11, and then 12 plus 6 plus 2, which is how much? 20, and then we have 6 plus 9 plus 4 plus 1, so 10 plus 20, 30. Similarly, next we have 12 plus 6 plus 2, that comes out to be 20, then 8 plus 3, that comes out to be 11, and then we have 4. Okay, but which is the value of the amplitude at time 0? How do I know that? Some student might say 4 is the answer, or maybe something else. No, you have to now check this samples. Okay, so x of n gives us the idea of the upper value of the function at which time. So 4 came at which time? So for that we have to say here n is 0, then 1, then 2, then 3. When time is 3, we got this 4, right? So time 3 is the maximum time. Here n is 0, so if I go previous, n is minus 1, minus 2, minus 3. So minimum time is minus 3, right? So here I will say this is n is equal to 3 maximum time, this is n is equal to minus 3 minimum time, and center would be n is equal to 0. Understood? Check it out. So your correct answer is what now? Your correct answer is 30. This is the answer, the value of the function when time is 0. That is your zero lag autocorrelation value of x of n. Understood why the answer is 30? Okay, let us go to the next question. The next question is, consider a filter defined by this difference equation where x of n, y of n are input output respectively. If the magnitude response of the filter at omega is equal to pi by 2 is mod h of pi by 2 is 0.5, the value of a is dash, rounded off to 2 decimal places. So be careful while writing the answer. Nevertheless, now let us see the solution. So the very first step is the difference equation. The difference equation was y of n minus 0.5 y of n minus 2, that is equal to a into x of n minus 4. Just recheck whether I have written correctly or not. Yes, I have written correctly. So now what's next? What's next is I will do the z transform. Okay, if I do the z transform, then y of z minus 0.5 z to the power minus 2 y of z, that is equal to a into z to the power minus 4 x of z, right? So y of z can be taken common from the left hand side. This is what is left inside the bracket, and in the right hand side we have x of z, and in the bracket we have a into z to the power minus 4. Therefore I can say my h of z, the transfer function, is y of z by x of z, which is equal to a z to the power minus 4 divided by 1 minus 0.5 z to the power minus 2. Now remember that here omega is used, so DTFT concept is used. So what we'll do now? What we'll do now is we will replace z with e to the power j omega. Okay, so if I do that, z is e to the power j omega, then we'll get our transfer function in terms of omega, which is a into z is changed as e to the power j omega. So this player would be e to the power minus 4 j omega. Denominator we have 1 minus 0.5 e to the power minus 2 j omega. Understood? If understood, then now what they are saying is mod of h of omega at omega is equal to pi by 2 is 0.5. So mod of this thing at omega is equal to what? Omega is equal to pi by 2. Oh no, we have to now add some free slides to comment on the answer. Now check it out. I'm taking this player from here, copying here, and then saying that mod h of omega is what? Omega is pi by 2. In that case, the answer should be what? Answer should be 0.5. Therefore, using this expression now, change omega to pi by 2. If you do that, this is what you are going to get. E to the power minus 2 j omega is changed as pi by 2, right? If that is the case, now tell me what is the value of a from this expression. Sir, the value of a, if you need, you have to see carefully that this is 2 1s are, 2 2s are, this is cancelled. Now this player is what? This player is, numerator is a into e to the power minus j 2 pi, and then denominator is 1 minus half e to the power minus j pi. Mod of the complete thing is equal to 0.5. So if you see carefully now, what is the value of this thing and what is the value of this thing? Let me show you here that e to the power minus j 2 pi, it is what? E to the power minus j theta, which is cos theta minus j sin theta. So cos 2 pi minus j sin 2 pi. This is 0, this is 1. So overall answer is what? Overall answer is 1. Whereas what is the value of this player? E to the power minus j pi, it is equal to cos pi minus j sin pi. So again sin pi is 0, cos pi is minus 1 now. So understood the calculations which are necessary to solve it further? If yes, then we can say a into 1 divided by 1 minus half into minus 1. So mod of that is equal to 0.5. Okay, let me take one more slide to get our final answer. Okay, so now do the copy paste from the previous to arrive at the final answer. And here I can say that a by 1 plus half, that is equal to half, which is now how much? A is equal to, here I can say it is coming out as 2 plus 1, 3 by 2. So half is multiplied with 3 by 2, which is 3 by 4, which is 0.75. So the correct answer is 0.75, correct up to 2 decimal places. So yes, that is the correct answer. Understood how to solve? So it was a good question, not very much tough, only a little bit of calculative, that's all. Let us go to the next question. Question number 25. The number of complex multiplications required for computing a 16-point DFT using the decimation in time DIT FFT radix 2 dash. Okay, so answer they need in integer. Very simple question, direct formula based question it is. See, they need what? They need a number of multiplication operator. Number of multiplication operator in DIT FFT. The formula is n by 2 log to the base 2 of n. So n here is how much? n here is 16 point DFT, so n is 16. So 16 by 2 log to the base 2 of 16, so this is 8 log to the base 2, and 16 can be said as 2 to the power 4. So 4 can be taken outside, and then we have log 2 to the base 2, which is 1. So 8 into 4 is finally 32, which is correct. Understood? Let us go to the next question. The Nyquist sampling frequency for x of t is 10 sine square 200 pi t is dash. Okay, so let us solve all the questions of signal and system subject, and these questions were asked in Electrical Gate 2023 paper. So the very first question in front of your screen, 30 seconds, because very easy question. A continuous time system that is initially at rest is described by this equation, where x of t is the input voltage and y of t is the output voltage. The impulse response of the system is what? A, B, C or D. So you have to just find h of t. Two-step process. First step, take Laplace of this equation, rearrange and get h of s. Second step, inverse Laplace transform. Got it? H of t, the answer is, if you are saying Calcutta, yes, Calcutta is absolutely correct. Okay. Now, those students who were not able to solve, focus here. First step, taking the Laplace transform of this above equation. So we are getting Laplace of dy of t upon dt is s times y of s. The next term, Laplace of 3y of t is 3y of s, that is equal to Laplace of 2x of t is 2 times x of s. Now in the left hand side, y of s can be taken common, bracket is s plus 3, right hand side 2 times x of s. Now rearrange y of s by x of s, that is equal to 2 by s plus 3. Now this thing is nothing but h of s. Once you got your h of s, then take the inverse Laplace transform to get the answer. Taking this solution to the next slide, so that we can take the inverse Laplace transform. Therefore, if we take inverse Laplace transform, the answer would be h of t is equal to 2 is constant, so it is outside. Laplace inverse of 1 upon s plus 3, this is shifting, which is done by exponential. So e to the power minus 3t into u of t. So this is the answer, which is Calcutta. So Calcutta is correct. Now we can move forward for the next question. Lot of questions were asked from signal and system subject, so it is becoming more and more important. Check it out. Next question based on the basics of signals. Check it out. NAT question. I will give you exactly 30 seconds because similar concept was asked in this branch only in the previous year, and I have solved it, so you know it very well. How to get the period of which signal? Of the signal x of n, which is described by this equation, and tell me what is the period rounded off to the nearest integer. NAT question, no negative marking. Sir, we have 3 function, this is DC component, so it won't affect our period. Next is this, where omega 1 is 15 pi by 8. Next term, omega 2 is pi by 3. Use the HCF concept, rearrange, get your answer. Okay, I should end the timer. It's not that tough. Check it out. The right answer is 48. Why? The very first step is getting the omega 1 from here and omega 2 from here. So omega 1 is equal to 15 pi by 8. Omega 2 is equal to pi by 3. Now, second step is if you need the fundamental frequency of x of n, we'll say it as, let us say, omega, which is equal to HCF of highest common factor between omega 1 comma omega 2, which is nothing but HCF of the fraction 15 pi by 8 comma pi by 3. How to get the HCF of a fraction? Sir, HCF of a fraction is HCF of numerator divided by LCM of the denominator. So this is now HCF of the numerator, which is 15 pi comma pi divided by LCM of denominator 8 comma 3. So what is common between 15 pi and pi? Sir, it's pi only common. Highest common is pi. What about the LCM of 8 comma 3? Sir, 8 comma 3, it's just multiplication. 8 into 3, that is equal to 24. So this is your omega. But apparently they were asking you the fundamental time period, not the fundamental frequency. So the final step is rearrangement. Since we know omega is equal to 2 pi by t, so if we rearrange, t is equal to 2 pi by omega, and here we can say that since t should not be written, they are treating t as capital N. So as per the notation, as per their notation, if they are saying capital N, okay, so 2 pi by omega was how much? Sir, from the previous you have told it is pi by 24. Okay, substitute pi by 24, so it is now 2 into 24, which is equal to 48. So 48 is absolutely correct, and we are done and dusted. So now we can move forward for the next question. So the next question in front of your screen, check it out. Third question. This seems to be tough, but frankly speaking, very easy question, can be solved in 30 seconds. Why? Because the question is the z transform of a discrete signal x of n is okay, x of z is given as 4z upon z minus 1 by 5 into z minus 2 by 3 into z minus 3 with ROC is R. Now you have to find a statement which is true from option A, B, C or D. So this is MCQ, only one statement is true. Tell me what is the statement. DTFT of x of n converges if R, which is nothing but region of convergence, is mod z greater than 3, or it converges when the region of convergence is between this range, or it converges when your signal x of n is a left-sided sequence, or it converges when your signal is a right-sided sequence. So what is the simple concept? Sir, DTFT converges when the region of convergence includes the unit circle. We have seen a lot of questions based on this concept. So which is that region which includes the unit circle? Check it out. In general speaking, we have 1, 2, 3, 3 poles. So 3 poles, 3 circles will come. You have to draw that first. If it was engineering paper, semester exam paper, we have to draw all these things. But in the GATE exam, you can solve this question little bit faster. Being a teacher, I have to give you the complete explanation. It's my duty. So suppose this is a z plane. Okay, this is a z plane, and then we have 3 poles. Let me go back and show you where are the 3 poles. So from here we can see the poles are at z minus 1 by 5, that is equal to 0. So z is equal to 1 by 5, which is 0.2. Next, z minus 2 by 3 equated to 0. So z is equal to 2 by 3. What's next? Z minus 3, that is equal to 0. So z is equal to 3. We have 3 poles. If you have 3 poles, make a cross. 1 by 5, 2 by 3. Suppose this is 3. Okay. 1 by 5, 2 by 3, and this is 3. Unit circle comes between this. Okay. Between this, unit circle will come. Nevertheless, if I make a circle from here, then my next circle from here, then the next circle from here, okay. So where is the unit circle? Sir, the unit circle is somewhere here, dotted I'm making so that you get the idea. Our region of convergence, if it includes the unit circle, then our DTFT converges. So this is the unit circle. Now check it out, option A. They are saying that the region is mod z is greater than 3. Mod z greater than 3 means the outside region. If you choose the outside region, this region do not include the unit circle. Check it out, unit circle is here inside, and your option A is saying region outside. So outside it is not including the unit circle. Hence we are saying that option A is wrong. It won't converge. Okay, DTFT of x of n does not converge in this range. Now what's next? Discrete time Fourier transform of x of n converges if mod z is greater than 2 by 3 but less than 3. Okay, mod z greater than 2 by 3 less than 3 is this range. This is your region. In this region we can clearly see that our unit circle is included. So this region is the region of convergence. Your DTFT will converge, and hence option B is absolutely correct. Sir, why Kolkata and Delhi is wrong? Please also tell us that. Why Kolkata, Delhi is wrong? It is wrong because when you say that left-sided signal, okay, left-sided sequence, take this pole and take the left-sided version. Okay, so mod z less than 1 by 5. If I take that mod z less than 5, will it include the unit circle? Mod z less than 1 by 5. Sir, it is not including the unit circle. Therefore, this region is not a region of convergence. And what about that right-sided sequence, Sirji? Right-sided sequence, again we have a case in the right-sided sequence, which means the greater, right? Greater. So if that is the case, again you can choose this mod z greater than 3. Mod z greater than 3 is that region where unit circle is not included, hence there is no region of convergence. We can comment that option Kolkata and Delhi are the wrong option because they are not including the unit circle. These regions are not covering the unit circle. Only Bombay was covering the unit circle, and hence we are saying that DTFT converges if ROC contains unit circle. Okay, so now this was our third question. Let us move forward for the fourth question. Now this is one of the good question which was asked in the electrical paper. Check it out. The Fourier transform x of omega of the signal x of t is given by this. X of omega is equal to 1 when mod omega is less than omega naught, otherwise the function is 0. Which one of the following statement is true? Option A, x of t tends to be an impulse as omega naught tends to infinity. Option B, x of 0 decreases as omega naught increases. Option C, at t is equal to pi by 2 omega naught, x of t is equal to minus 1 by pi. Option D, at t is equal to pi by 2 omega naught, x of t is equal to 1 by pi. So GATE 2023 electrical, tricky question. Why? Because frequency function is given. Find the respective time domain function, then only you can comment on the options. One way is to use the formula, other way is you know that this is the standard graph, rectangular function. So the time domain signal would be a sinc function, sampling function. So the time is up. Now it's my time to solve the question. Okay, now focus. If you got the answer as option A, then congratulations, option A is absolutely correct. But why? Let us see. The first thing is to get your time domain function. So x of omega, if I draw the function, it is a rectangular function with constant amplitude 1, and it is working from minus omega naught to omega naught, correct? So this is our x of omega graph. Now if you need the x of t graph, we know it very well, rectangular, then the time domain would be a sampling function. So our sampling function is equal to sine omega naught t, whatever is the value here, that only comes. If it was omega naught by 2, here it is omega naught by 2. We have learned that in the basics. So sine omega naught t divided by pi t. This is the first step. Now the second step is they were asking us the value of this function x of t at t is equal to pi by 2 omega naught. Copy this to the next slide. and then substitute t is equal to pi by 2 omega naught. If I do that, then x of t is now sine of omega naught into, check it out, t is replaced as pi by 2 omega naught, the whole divided by pi into, again we have a t, so t is replaced by pi by 2 omega naught. So what I can see here is clearly omega naught getting cancelled and sine of pi by 2 is 1. So the numerator term is 1, and the denominator term we have here in the denominator pi into pi square, and this 2 omega naught goes to the numerator. So therefore the final answer is 2 omega naught divided by pi square, which means clearly that Calcutta and Delhi both are wrong, because pi is not there in the denominator. Pi square should be there. Very simple observation, right? So this is gone, Calcutta and Delhi is gone, A or B is left. So here I will write from this option C and D is wrong. So now we can move forward and we can investigate. Now the investigation part is, check it out, I guess they were saying that x of 0 decreases as omega naught increases is one of the option. The other statement, x of t tends to be an impulse as omega naught tends to infinity. Now check it out, if you make this omega naught tending to infinity, which means you are increasing the width and you are stretching towards the infinity. Similarly here also you are stretching towards the infinity. If that happens, can I say this graph will behave as a DC signal, amplitude 1 always? And for that, if the response is amplitude 1 always, what is the respective time domain signal? So it is delta of t. So let me write it here. If you are manipulating your x of omega graph as point number 3, if you are increasing the width, omega naught tends to infinity, the graph now looks like this is omega and this is x of omega graph. Now this is 1 throughout. Okay, so if that is the case, then x of t is equal to delta of t. Again the standard results which we know. If you do not know, you have to use the formula. Once you know this, that x of t is equal to delta of t, obviously the next point comes to your mind, that they were saying that x of t tends to be an impulse, which is absolutely true. We have seen when you are increasing omega naught, which is nothing but the width, it behaves as a DC signal, which is amplitude 1. If you have a frequency response where the amplitude is 1 always, then this DC signal response is happening when you have a impulse function. So x of t is equal to delta of t. That is absolutely true. If that is true, we are done. Option is correct. But the question is why Bombay is wrong. That is also interesting to know, that x of 0 decreases as omega naught increases. They are asking relationship of x of 0 and omega naught. See, x of t, we know it very well. If you know x of t very well, then x of 0 can be found. Check it out. This is our fourth point. Can you find x of 0? If I substitute t is 0, then x of 0 is equal to sine of omega t is replaced as 0 pi into, oh, so this is 0 by 0 form. If this is 0 by 0 form, we have to use the L'Hopital. Therefore, if we use the L'Hopital, what we get is differentiation of numerator. Let me write in this way, limit t tends to 0 sine of omega t divided by pi t. Now one way is to use the L'Hopital, other way is to say that when t tends to 0, sine of omega naught t is behaving as omega naught t, and then you can do the tt cancellation. Omega naught by pi would be the answer. Other way is to use the L'Hopital and you have to do the calculation. Anyhow, the answer is omega naught by pi. Both the methods I have told you. So you can see the relationship that x of 0 is directly proportional. You can see the equation, x of 0 is directly proportional to omega naught. If it is directly proportional to omega naught, so when x of 0 increases, omega naught should increase. But in the option, what they were saying? In the option Bombay, they were saying that x of 0 decreases when omega naught increases. Inverse relationship. That is not true. So Bombay is wrong, Calcutta is wrong, Delhi is wrong. Only option A is correct. So we can see here from this slide, Calcutta, Delhi was wrong. From this slide, option A is correct. Let me write it here. Hence, option A is correct. Okay, and from this slide we know it very well that x of 0 is directly proportional to omega naught. So that was not there in the option Bombay. They were telling about the inverse relationship, which was incorrect, hence Bombay is incorrect. Now let us move forward for the next question. Again, one of the interesting question, because every option you have to analyze. You can see this is kind of 4 question in one. Hence student says that the paper is very difficult, because we have to check every option, and that is like 4 questions in one. This is MSQ. Which of the following statements is or are true? Now this is little bit controversial also. Let us see whether you can solve this question or not. Option A, if an LTI system is causal, it is stable. Option B, a discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n less than 0. Option C, if a discrete time LTI system has an impulse response h of n of finite duration, the system is stable. Option D, if the impulse response is like this, mod h of n is greater than 0 less than 1 for all n, then the LTI system is stable. What do you feel? You have to check each and every statement. MSQ questions, every option you have to analyze, you have to rethink whether you are not missing any of the point. If you miss any of the point, you will make blunder and you won't get any marks. Okay, take your time. I will give you 1 minute 30 seconds, and I guess that's enough, because the question is not that tough. Last 15 seconds to go. Okay, last 5 seconds. 4, 3, 2, 1, done. So the answer is only one option correct. You know what is that option? That option is this. This option is only correct. And obviously, sir, why this option is only correct? Because first option is absolutely wrong. If an LTI system is causal, it should be stable. Who said that? Suppose you have a signal e to the power t u of t. Is it causal? Yes. But is it stable? No. Increasing function, unstable. Okay, so this is not stable. So you got the answer. LTI system was causal, but it was unstable. So saying this statement as LTI system is causal, it is stable, is wrong statement. Okay. Now, option Bombay. A discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n is less than 0. Now this is very interesting. What they are saying is that LTI system is causal if and only if, then blah blah blah. First you have to analyze this statement. A discrete time LTI system is causal. When a discrete time LTI system becomes causal, sir, when it satisfies this criteria. What is the criteria? Let me write it here, that causal LTI system should follow this criteria. H of n is equal to 0 when n is less than 0. Now we understood this thing. LTI system is causal, but then they are saying if and only if its response to a step input is 0 for n is less than 0. Now can I say that the input they are giving is a step input, so the response we'll get is a step response. So let us analyze that step response, how it would look like. So as per the given statement, they are saying that the input is a step input which is u of n, and then the response, the output, which is y of n is equal to x of n convolved with h of n. Agreed? So here we are getting a step response. Step response generally in notation s of n we say it. Nevertheless, therefore here we'll say that y of n, just for the notation, if you want to write s of n, that's okay. I'm just writing y of n as the output. Output is input was u of n. Okay. Let me also highlight this, that our input notation we generally give as x of n, and that is equal to u of n. So if I do the substitution, u of n convolved with h of n, and obviously when u of n is 0, when n is less than 0, then the output is also 0 when n is less than 0, after doing the convolution also. Therefore we'll say that y of n is equal to 0 when n is less than 0. So if they are saying that a discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n is less than 0, makes sense. This is absolutely correct. We have proven, okay, that input was u of n. We did the convolution, we got the output. So output is 0 when n is less than 0. Why? Because this value is 0, 0 convert with h of n, answer would be 0 only. Now, next is Calcutta and Delhi. Calcutta is little bit tricky. Mark it star. Why it is tricky? Because this is may or may not be true. If a discrete time LTI system has an impulse response h of n of a finite duration, this system is stable. See, the concept is it should be absolute summable, which means summation of h of n should be less than infinity. But what if the amplitude, this finite duration, has an amplitude which is infinity? Then if you add the signals, then the answer would be infinity. If the answer is infinity, then it is not stable. For stability, summation of h of n should be less than infinity. I am saying in this, if we got some amplitude which is infinity, so in the summation, the resultant would be infinity. So if we get infinity, it becomes unstable. Hence, that part about the amplitude is not mentioned in this statement. Hence, we cannot comment about 100% stability. Okay, if they are saying we have a finite amplitude, we have amplitude such that it's not getting converted to infinity after summation, then we would say with 100% confirmation, okay, then the system is stable. But here that was not given. Hence, we cannot say this statement can be absolutely correct. Okay, this is may or may not be true. And finally, Delhi, if the impulse response is this, then the system is stable. Now this is tricky because here mod of h of n, basically amplitude nature they are giving us, that amplitude nature of h of n is between 0 to 1. Okay, so if I try to do the summation, suppose h of n is 0.8, 0.8, 0.8, many terms like this sampled we have. Okay, so if I try to add them, 0.8 plus 0.8 plus 0.8 plus so on and so forth, sir, the answer would be infinity. Yes, if the answer is infinity, then how come this LTI system is stable? If the answer is infinity, it should be unstable. Okay, so sir, we got it. This statement is wrong. Because when h of n is 0.8, which is in this range, we are getting, after doing the summation, answer as infinity, which makes it unstable. So, saying it's stable is wrong. So, what's right? Which statement is true? Only Bombay is true. Easy. We can move forward for the next question now. So, the next question in front of your screen, check it out. So in this video, we are going to solve signal and system questions which were asked in GATE ECE 2023 paper. So the first question in front of the screen, very easy question, only 30 seconds I will give. Consider a system with input x of t and output y of t is equal to x of e to the power t. This system is, now there is a combination, causal, non-causal, time variant, invariant. This is what you have to check. So A, B, C, D, only one option is correct. MCQ question asked in GATE 2023 ECE paper. You have to save time in this easy question so that you can invest your remaining time in the hard question. Always remember, time management is very, very important in the GATE exam. Okay, so the time is up. Let us see what is the right answer. If you are commenting Bombay, yes, option B is absolutely correct. Why? Let us see. So the first step is checking causal, non-causal. We have the system as y of t is equal to x of e to the power t. Okay, so when I substitute t is equal to 0, then the equation becomes y of 0 is equal to x of e to the power 0, which is x of 1. What does this mean? Sir, our present output y of 0 is depending on the future input. So when the output is depending on the future input, this is the case of a non-causal system. Therefore, you can write it here that the present value of output depends on future value of input. Whenever this happens, then the answer is non-causal system. Since it is a non-causal system, two options are eliminated. Let us go back and see which options are eliminated. Sir, A and C is eliminated because they are saying that the system is causal, whereas our system is a non-causal system. So now for B and D, which one is correct? To check that, we have to find the time variant and invariant stuff. So to the next slide, let us find whether the system is time variant or invariant. It's a two-step process. Our equation was y of t is equal to x of e to the power t. First, you have to delay the input by k units. So let us say the output in that respect is y1 of t. So when I delay my input with k units, e to the power t minus k will happen here, since input is delayed by k units. Now the second step is replace. Wherever you have t, replace with t minus k. So in that case, the respective output, let us say y2 of t is equal to x of e to the power, replacing a t with a t minus k. So you can see this is replacing t with t minus k. Now my question to you is, see this first output and the second output. Are they same? No, Sarji, they are not same. Here we have x of e to the power t minus k, and here we have x of e to the power bracket t minus k. So both of them are different. When both of them are different, the conclusion is they will be dependent on the time. So y1 of t is not equal to y2 of t. Therefore, the system is time variant system. Simple. So if it is a time variant system, go back and check which is that option. Non-causal and time variant, Bombay is absolutely correct. Let us move forward for the next question. You can see that this type of concept are repeated over and over in electrical paper also, iron paper also, ECE paper also. So previous year papers concepts are very, very important because question won't repeat, concept will definitely repeat. Let us go for the next question. Question number 2 in front of a screen. Easy question, check it out. So basically DTFT is given. Let an input x of n having a DTFT, discrete time Fourier transform, like this, we pass through an LTI system. The frequency response of the LTI system is this thing. So can you find the output y of n? They are asking the output in the time domain. Given stuffs are Fourier transform, frequency domain. Okay, how you will solve? Sir, in LTI system, output is x of n convert with h of n. Use the DTFT, convolution change to multiplication, substitute, then reverse form, inverse discrete Fourier transform, you will get the answer. Very simple, very easy. If you feel that doing inverse DTFT is difficult, Sarji, then use Z transform concept. It's pretty easy. So yes, it can be solved in 45 seconds. So I will end the timer. If you are saying the answer is Calcutta, then yes, it is absolutely correct. Why? Let us see. It's only calculation, that's all. Nothing more here, no more difficult concept, only simple calculation. In LTI system, y of n is equal to x of n convert with h of n, correct? And then if I take DTFT, then I can say y of e to the power j omega that is equal to x of e to the power j omega, convolution change to multiplication, and then h of e to the power j omega. Now x of e to the power j omega is given in the question, that is 1 minus e to the power minus j omega, then we have plus 2 times e to the power minus 3 j omega, then we have to multiply this complete stuff with 1 minus half e to the power minus 2 j omega. This is what our h of e to the power j omega was. Okay, go back and check whether we have substituted it correctly. If yes, then every term from here would be multiplied to this term, then this term multiplied to every player, this term multiplied to every player, expanded version, collaborating that, and then what you will get is this. Check it out. Therefore finally I will say y of e to the power j omega, after opening and combining the common terms, we are getting 1 minus e to the power minus j omega, then plus 2.5 e to the power minus 3 j omega, then minus 0.5 e to the power minus 2 j omega, and minus e to the power minus j 5 omega. This is what we are getting. Now they needed the output not in this frequency domain but in the time domain. Therefore now if you want to convert this thing into the z transform, that also you can do. E to the power j omega is replaced as z. If you do that, then y of z is equal to 1 minus z to the power minus 1. Now take this term next, so minus 0.5 z to the power minus 2. Now take this term next, replace e to the power minus j omega as z, then plus 2.5 z to the power minus 3, and then finally we have minus e to the power, oops, not e, we need z, right? So z to the power minus 5. Okay, now it's easy. If I need the respective time domain signal, I can say either in the form of the sample, or if you want to write in the impulse form, as they are commenting that ABCD, you need the impulse answer. So we can say when n is 0, the amplitude is 1. So here we can say 1 into delta of n. Next, when n is equal to 1, the amplitude is minus 1, and if that is the case, minus 1 into delta of n minus 1, right? And similarly you have to move forward. For the next player we have minus 0.5 delta of n minus 2, then plus 2.5 delta of n minus 3, and then there is no delta of n minus 4, then we have minus delta of n minus 5. So yes, this is the final answer. Now if I go back and check, this is matching with which of the following. Delta of n was positive, then we got negative delta of n minus 1, so A and D is eliminated. Then we got minus 0.5 delta of n minus 2, then obviously we can say that this were wrong, then here it is same. Okay, then if I check delta of n minus 3, negative, it was not, it was positive 2.5, so yes, Calcutta is correct. Okay, in this way you can say Calcutta is correct. Very easy question, very simple question based on the basics. Let us move forward for the next question, and this next question is a very famous concept of GATE examiner, asked many times in the previous year papers, and again they are asking here. GATE 2023 telecommunication, the Fourier transform x of omega of x of t, that is equal to e to the power minus t square, is what? So this is the time domain function. They are asking the Fourier transform of that. One way is to use the integration and solve, but that is a very lengthy approach. Other way is you know the standard results. If you know that, life is simple. And believe me, this is a very famous function, Gaussian function. So it's necessary, it's important you know the Fourier transform of this thing. Okay, I guess 30 seconds is enough. In that 30 seconds, you should be able to comment on the answer. What is the answer? Let us see step by step. So the method 1, let me write it here, is solving integration. But I will not do that. I will use the method 2, which is using the standard result. If you know the standard results, which is if you have e to the power minus at square, then the Fourier transform of that is root pi by a, then e to the power minus omega square by 4a. If you check it carefully, sir, here in the question the value of a is 1. So here in our answer, if I substitute a is 1, I will get the final answer. So here a is equal to 1, therefore e to the power minus t square the Fourier transform of that is root pi e to the power minus omega square by 4, where you can see that, sir, it is there in Calcutta, so Calcutta is absolutely correct. Okay, so now we can move forward for the next question. Can you see how easy the questions are? Sir, all the questions were easy? Not at all. There was a mix of easy, medium, tough. But always remember that easy to moderate 80% question, very very hard 20% question. This ratio will remain throughout in any year you write the GATE exam, okay, and in any subject, any branch. Now to the next question, check it out. NET question, 2 marker, no negative marking. Let x1 of t is equal to u of t plus 1.5 minus u of t minus 1.5 and x2 of t is shown in the figure below. For y of t that is equal to x1 of t, convert with x2 of t. Then the integration value, integral minus infinity to infinity y of t dt is dash, rounded off to the nearest integer. So this is the x2 of t graph and x1 of t is written in form of the equation. If you see carefully, you might be thinking of Fourier transform concept and then getting the answer. That is not wrong, but obviously it is time taking and hence I won't follow. There is a trick to solve this question. So I told you method 1 is the Fourier transform which you are following, that y of omega is equal to x1 of omega into x2 of omega, and then to get the integration answer you will substitute omega is 0 and you will solve it. Okay, I won't do that. So the time is up. I guess this question can be solved in 30 seconds. How, Sarji? How? Check it out. So the first step is to copy this graph. Okay, let me write it in this way. First step is what they are asking. Sir, they are asking integration answer. Okay, if they are asking integration answer, integral minus infinity to infinity y of t dt, what is this? Sir, engineering mathematics I have studied from you. This is area under curve. Okay, so which is that curve? Sir, area under the curve y of t. But sir, y of t is not given directly. So what it is given? Sir, they are saying y of t is convolution of x1 of t with x2 of t. So area under y of t is nothing but x1 convolved with x2. That is nothing but x1 of t convolved with x2 of t. So the trick here is what I told you. A lot of students will use method 1 using the Fourier transform concept to solve the question, but I am saying to use the method 2. Method 2 is basic trick shortcut, which is the result that area under x1 of t convolved with x2 of t is simply area under x1 of t multiplied with area under x2 of t. That's all. If you do that, you will get answer in seconds. Now let us go back and see. x1 of t is not given directly. We have to make graph. x2 of t is given here. Can you comment on the area? Sir, here the area is 1. Here the area is 2. Sir, here we can find the area rectangle. So base into height. Base is 2, height is 1. So area is 2. So final area 2 plus 2 plus 1, 5. Easy, done. Let me go to the next slide and again write that in a proper form so that when you refer notes you get the idea completely. What I told here, that this is where you get area 1, this is the version where you get area 2, and this is the rectangle where you get the area. Base is 2, height is 1, so 2 into 1, the area is 2. Okay, so final answer that the area under x2 of t is equal to 2 plus 2 plus 1, that is equal to 5. Now when I talk about x1 of t, they were giving us the equation. So what was the equation of x1 of t? Sir, the x1 of t equation was u of t plus 1.5 minus u of t minus 1.5. So this is a rectangular pulse again. Okay, so if you draw this, check it out. If you draw this, so this is what you will get. This is time, this is y-axis which represents x1 of t, and then this is the graph which says it's working in a range of minus 1.5 to to plus 1.5. I hope you know how to plot that. I'm just skipping some steps, only 2 steps, drawing this, and then subtracting the common parts, and this is the uncommon part which is remaining. Okay, nevertheless, now I can move forward and I can say the amplitude here is 1. And what about the area? Sir, this is rectangle, so base is 1.5 plus 1.53 and the height is 1, so the area is 1 into 3, that is equal to 3. So I will write here area under x1 of t is equal to 3. So now what is our answer? Sir, check it out. Copy this to the next slide and then happily say that we found this. First, area under x1 of t is 3. The next, we found it 5. So 3 into 5, the answer is 15. Was it simple? Was it easy? So if you know the tricks and techniques, it is easy. Otherwise, use the concept of Fourier transform, convert these pairs, write it, solve the integration, get the answer. Okay, but this one was little bit easy. You can check it out. Area under x2, area under x1, just multiply them, got the answer. Let us move forward for one of the good question which was asked in the paper. And again I will tell you, if you know the tricks and techniques, you can solve this question pretty fast. If you do not know the tricks and techniques, I will show you how to solve this question in 2 minutes. Okay, so I will give you 2 minutes. Okay, I won't give you 2 minutes, I will give you exactly 1 minute. The question is, let m of t be a strictly band limited signal with bandwidth b and energy E, assuming omega naught is equal to 10b. The energy in the signal m of t into cos omega naught t is dash a, b, c or d. Okay, so this question is based on the energy concept, and you can see that time domain signal, energy is E. Again one more time domain signal, energy is asked. So when cos of omega naught t is multiplied, can I say it can be converted into exponential version? What is cos theta? E to the power j theta plus e to the power minus j theta upon 2. Convert that and then think, and then you can get the answer. Okay, last 10 seconds to go. So 5, 4, 3, 2, 1, done. What is the answer? The answer is Bombay, and I will give you both the methods, method 1 and method 2, but starting with the lengthy method first. So yes, so we are live. Good morning everyone. Welcome to previous year paper solution class. So in the today's class, we are going to solve instrumentation 2022 gate questions of signal and system subject. Let us start with the very first question. So the first question in front of your screen, the input x of t to be a system is related to its output y of t as dy of t upon dt plus y of t, that is equal to 3 times x of t minus 3 into u of t minus 3. Here u of t represents a unit step function. The transfer function of the system is dash. So your time starts now. It will take hardly 1 minute to solve this question. Basically, time domain signal is there and they are asking the transfer function of the system in the S domain. So indirectly we have to use the Laplace domain concept. So use the Laplace domain concept and tell me what is the answer. There are some crucial terms here. So you should know two properties, otherwise you won't be able to solve this. First property is, you can see that time is shifted, so time shifting property. The second point is Laplace of derivative. If you know these two concepts, life is simple, because transfer function is just y of s upon x of s. Output version of Laplace divided by input version of Laplace. Okay. Finally, 15 seconds we have. Tell me guys, what is the answer? And I guess audio video is very clear. Yes. Okay. So the interface has changed. That's good. So 3, 2, 1, time is up. Now it's my time to get the answer. What to do? First of all, we use the Laplace transform by saying, let us take Laplace transform on both the side of the expression. Laplace of y dash of t plus y of t, that is equal to Laplace of 3 times x of t minus 3 into u of t minus 3. Correct? Now, Laplace of y dash of t, you know, right? Laplace follows linearity property. If it gets distributed, it will go to this term and also to this term. So Laplace of derivative is s to the power 1, because it is only one derivative. Then y of s minus y of 0. And you might be asking, sir, what is y of 0? Nothing is given in the question. Check it out. If nothing is given, by default it is 0. If something is given, then you have to substitute that also. Okay. So here nothing is given. So by default this term is 0. Next term we have is Laplace of y of t, which is y of s, and that is equal to Laplace of this stuff. Constant, it can go outside because Laplace follows the integration property. So in our integration also we take the constant outside. What about Laplace of this term? X of t minus 3 into u of t minus 3. Sir, time shifting property. As per the time shifting property, every time is shifted at one place only. So we can sort it by using e to the power minus 3s. Then Laplace of x of t into u of t. What's next? So Laplace of x of t into u of t, by the table we can say that this is capital X of s. I'm like, everything is done then. Check it out. In left hand side, y of s can be taken constant. S plus 1 is there in the bracket. In right hand side, 3 times e to the power minus 3s capital X of s. You needed the transfer function. Transfer function is y of s by h of s. Y of s by x of s. And that is equal to, this thing would be in the numerator, 3 times e to the power minus 3s divided by, this thing will go to the denominator as s plus 1. So yes, this is your answer. This is your transfer function, which is present in which option? Check it out. This is present in 3 times e to the power minus 3s. Is there in B and C? No, only B. So B is correct. Understood? Then do let me know in the comment section. Yes. Always remember that transfer function is represented as capital H of s, which is basically y of s by x of s, and this is known as the transfer function. Sometimes only TF is also written. Okay, that is the short form. Let us go to the next question. So the next question in front of your screen is this. There are limited questions asked from the signal and system subject. So tell me guys, what is the answer? One of my favorite topic, classification of system. The output of a system y of t is related to its input x of t. According to the relation y of t, that is equal to x of t into sine of 2 pi t. This system is linear, non-linear, time variant, invariant, all the combinations are there. Tell me guys, what is the answer? I will give you 1 minute to solve this question. Okay. Now by seeing this question, some students feel that, sir G, sine term is a non-linear term. So non-linear graph, so it should be non-linear system. That is a wrong analogy, wrong logic to solve this question. There are some steps through which we can identify linear, non-linear. Like in the differential equation, we used to follow this step to find linear differential, non-linear differential equation. Similarly, here also we have some steps. If you follow those steps, you will get the correct answer. Otherwise, if you use random logics, you will get random answers. So finally, the time is up. Now it's my time to get the answer. First of all, you have to check it out. To find whether the system is linear or not, there are only 4 steps. Yes. What was the equation? The equation was y of t, that is equal to x of t into sine of 2 pi t. Correct? The first step is, if my input is x1 of t, what should be my output? Sir, y1 of t. Okay. So my input is only changed. This is my input. This is my coefficient of the input. Okay. So this is not changed. This is changed. X of t is changed as x1 of t, and my coefficient is still sine of 2 pi t. Suppose my input, I was asking that if my input is x2 of t, what should be my output? Sir, your output should be y2 of t. And who is changed? Only input is changed, right? x2 of t. What about the coefficient? Sir, coefficient is still unchanged. Now suppose I ask you to find y dash of t. This is not derivative. Please note it down. This is not derivative. Y dash of t is made by addition. y1 of t plus y2 of t. So if I add two equations, what I will get? Sir, coefficient is common. This two would be added. So I can say that my uncommon terms are getting added. x1 of t plus x2 of t. The common term is getting outside, sine of 2 pi t. For now, everyone clear? Crystal clear? If yes, then the last step is, if my input is x1 of t plus x2 of t, then what would be my output? For say my output is y double dash of t. Note it down, y double dash of t is not the double derivative. It is just the denotion. It is just the symbolic form of saying that if my input is x1 of t plus x2 of t, this is how the output would look like. Now input is where this thing, this is replaced as this stuff. Therefore my output is now x1 of t plus x2 of t, and then the coefficient outside, sine of 2 pi t. Now check it out. Is your y dash of t and y double dash of t, are they same? If they are same, then they are linear. If they are not same, they are non-linear. Now tell me in the comment section what it is. Everyone in the comment section. Is it linear or non-linear? Tell me. Sir, we can see clearly they are same. Therefore, it is linear system. Understood the steps, understood the technique, then do let me know in the comment section. Yes, this is very, very simple technique to get whether a system is linear or non-linear. Okay, through PYQs I will tell you the steps also how to solve in future. In every paper classification of system is asked, so it's very important topic. Linear, non-linear, causal, non-causal, time variant, invariant, stable, unstable. These topics are asked in almost every paper. So y dash of t, y double dash of t, they were same. Therefore we will say it is linear system. Linear system means two options are eliminated then. Which options are eliminated? Option D and option B is eliminated. Now A and C, which one is correct? Sir, time variant, invariant we have to check. Sir, how to check time variant or invariant? Do not worry, we have steps again. We have steps again. Copy this equation and now ask yourself, what if I do delay and replace? What is, sir, delay and replace? These are the two steps. First step is you have to delay. Delay whom? Delay only the input, not the coefficient. Who is the input here? Sine or x? Sir, x of t is my input. So delay this input by k units. If I delay the input, what is my output? Let us say y1 of t is my output. My input is delayed by k units. So x of t minus k. Then I have sine of 2 pi t. What if I do the replace? Sir, whom to replace? Everywhere, wherever t is there, replace by t minus k. So therefore, Sirji, my output now would look like wherever t is there, in input, in coefficient, wherever it is there, replace t by t minus k, and now check whether y1 of t and y2 of t are same or not. Tell me guys whether they are same or not. Sir, clearly these two are not same. If they are not same, they are dependent, they are time variant, they are not time invariant. Okay. So if they are not equal, this means dependency is there, time variant it is. Understood? Then do let me know in the comment section. Yes. So this is time variant. Only two steps. Delay the input by k units, replace everywhere t with a t minus a k, and check whether they are same or not. If same, then time invariant. If not same, time variant. So time variant and linear system, it is present in time variant, and linear system is there in option A. So option A is absolutely correct. Understood? Then do let me know in the comment section. Yes. Okay. So the next question in front of your screen. Check it out, guys. Next question. Sir, all the questions seems a little bit lengthy. Not so much lengthy. Check it out. GATE 2022 iron question. The signal x of t that is equal to t minus 1 the whole square into u of t minus 1, where u of t is the unit step function, has the Laplace transform capital X of s. The value of x of 1 is dash, A, B, C or D. I will give you exactly 1 minute. Do not worry. See, for those students who are learning signal and system, you have Laplace transform and Fourier series, which is common to all branches in engineering mathematics subject. So I have covered the Laplace transform and Fourier series in engineering mathematics. So you haven't learned all this concept, then go learn from those conceptual courses. It's very, very simple. It's free marks, almost free marks. So final 15 seconds. Tell me guys, what is the answer? 2 steps. First, convert x of t into capital X of s, then replace s with 1. Done. Okay, so 5, 4, 3, 2, 1, done, dusted. Tell me what is the answer. Okay, so the right answer is Bombay. How it is Bombay? Let us investigate. First step you have to do is Laplace on both these sides. So Laplace of x of t, that is equal to Laplace of t minus 1 the whole square into u of t minus 1. So Laplace of x of t is capital X of s. Laplace of this thing, sir, again time shifting. If time shifting is there, how you will solve? Sir, if time shifting is there, first I will check time is shifted at the same positions. Yes, then I can say e to the power minus s, and now everything would come at origin. So t minus 1 the whole square, if it is at origin, it would look like t square. This at origin is u of t. Now this is the table which we have studied, sir. From you it is very simple. T to the power n, the Laplace of that is n factorial divided by s to the power n plus 1. Therefore this is 2 factorial divided by s to the power 2 plus 1. But remember, this is capital X of s. They needed when s is equal to 1, what will happen? E to the power minus 1, this is 2 factorial divided by 1 cube. Sarji, this is 2 by e. This is my final answer. 2 by e is there in Bombay, so Bombay is absolutely correct. Understood? Let us go for the next question then. Okay, sir, things are getting easier now. Then paper is like not so easy, Balak. Check it out. We have next question, which is based out of Fourier series. This topic is dangerous for some students, but for our students it's very easy because we have studied conceptually, by tricks, by every methods, right? So now the question is, a periodic function f of x, so with period 2, is defined as f of x that is equal to minus 1 minus x when x is ranging from minus 1 to 0, and this function is 1 minus x when x is ranging from 0 to 1. The Fourier series of this function contains a dash. What do you think? What it contains? Does it contain only sine, only cos, or only cos of this as the angle 2n pi x, or maybe both cos and sine? Come on guys, last 20 seconds to go. Now there are some students who says, sir, Fourier series seems very, very tough. Why? Because sir, we have learned this topic. We have just by hearted the formulas. Therefore, it feels very, very tough. Is there any easy way? Then study conceptually. If you study conceptually, everything is pretty easy. Check it out. First of all, we have to check whether this function is even or odd. Once we understand even or odd, then we can comment on the options. So yes, we are live. Good morning everyone. Welcome to previous year paper solution class. So in the today's class, we are going to solve electrical gate 2021 gate questions and the section is signal and system. So let us start with the very first question in front of your screen. Gate 2021 electrical question number 1. Two discrete time linear time invariant systems with impulse response h1 of n that is equal to delta of n minus 1 plus delta of n plus 1 and h2 of n is equal to delta of n plus delta of n minus 1 are connected in cascade, where delta of n is the Kronecker delta that we also know by default by the symbol. Nevertheless, the question is now the impulse response of the cascaded system is what? A, B, C or D. So your time starts now. So tell me guys, what is the answer? So this question is pretty simple. 1 minute is enough. I will give you exactly 1 minute. Okay, so last 30 seconds. If two impulse response are connected in cascade, this means they are connected in series. So tell me what is the resultant impulse response. That's all. Pretty simple. The function is simple, the concept is simple. Last 15 seconds. Okay, so the countdown begins now. 8, 7, 6, 5, 4, 3, 2, 1. The right answer is Bombay. Why? Let us see. First of all, the cascade system means the series concept. Input goes to the first impulse response. So let us say this is H1. Then it goes to the second impulse response. So this is H2. And then we get the output. Okay. So what happens when I talk about the resultant impulse response? The resultant impulse response, let us say h of n, that is equal to h1 of n, because we are in discrete time, convolved with the next impulse response, that is h2 of n. Correct? Now if I see carefully, h1 of n, h2 of n, they are given as a function, and when you do the convolution, it's time taking. If you do time domain convolution, it's very time taking. So better we'll go with the frequency domain, and because we are dealing with the discrete time, so let us use the Z transform. If I use the Z transform, then I can say h of n transformation in frequency looks like h of z, h1 of n becomes h1 of z, convolution gets converted into multiplication. That is the benefit in the frequency domain, and then h2 of n converted into h2 of z. Now see carefully, h1 of n was given as delta of n minus 1 plus delta of n plus 1, correct? If you do not know how to convert this function into Z transform, then you have to clear your basics first, but I will give you concepts so that there is no issue at all for you guys. So you can write the concept. The concept is whenever you have a function of delta of n plus a, the Z transform of that is Z to the power whatever is there here straight away to the power. Suppose you might get a delta of n minus a, then Sarji, the Z transform is Z to the power whatever is there here straight to the power of Z. Got it? Easy peasy, lemon squeegee. Now check it out. H of n was given as delta of n minus 1 plus delta of n plus 1. So the Z transform becomes Z to the power minus 1 plus Z to the power plus 1. Correct? The next, h2 of n was delta of n plus delta of n minus 1. So we will say z to the power 0 plus z to the power minus 1. After multiplication, what is the resultant? Sir, this thing z to the power 0 is 1. Correct? So we will say z to the power minus 1 into 1, z to the power minus 1. This thing into this thing becomes z to the power minus 2. Next, this thing into this thing becomes z. This thing into this thing becomes 1. But sir, this is the answer as h of z. We need the answer in h of n. No problem at all. Use the inverse Laplace transform and get the answer. So now if I use, not inverse Laplace but inverse Z transform. So if I use the inverse Z transform, then I will get my answer. So h of n, that is equal to, what is the inverse of this now? Sir, check it out. Z to the power minus a, inverse would be delta of n minus a. So can I say this thing becomes a delta of n minus 1. Similarly, this thing becomes a delta of n minus 2. This thing becomes a delta of n, and finally we have constant. Oops, not delta of n here. This is power 1, so n plus 1, and then constant is said as delta of n. Okay, so this is the final answer. We have minus 1, minus 2, plus 1, n. Minus 1, minus 2, plus 1, n. In Bombay, so Bombay is absolutely correct. Understood? Then do let me know in the comment section. Yes, because this is method 1 to solve this kind of question. Using the Z transform to get the answer, this is method 1. There is one more way to solve this question. Do you want to see? There is one more way. Check it out. There is another concept. You can solve this question in time domain only. There is no need to go in the frequency domain. Why, Sarji? Because method 2 is all about the time domain concept. The concept is, if you have a signal x of n, when it is convolved with the delta, like a delta of n, then this delta of n behaves as wife, and this x of n behaves as husband. If wife says you have to go to the mall, husband follows to the mall. If wife says you have to go to the coaching, then husband follows the coaching, bring your child. If wife says you have to cook in the home, then husband follows, okay, we'll cook in the home, we won't order from the hotel. Similarly, here also, if delta of n says that I will work at n is equal to 0, this function also says I will work there only. But now if the delta is saying that I will work at n minus a, then husband will follow that point, right? So the resultant would be x of n minus a. Understood this concept? Then do let me know in the comment section. Yes, because by this concept, this question can be solved again. Okay, so now you can see that we had the question resultant h of n is equal to convolution between the two time domain signal in the discrete version, and h of n, h1 of n was delta of n minus 1 plus delta of n plus 1 convolved with h2 of n, that is delta of n plus delta of n minus 1, correct? Now this thing convolved with this thing plus this thing convolved with this thing. Similarly, this thing convolved with this plus this thing convolved with this. So 4 terms we will get, but while solving the 4 terms, be cautious. When this thing is convolved with this, it is behaving like this. What is the resultant? X of n convolved with delta of n. The resultant should be x of n. So I hope you understood. This thing will come as the output. So when this thing convolved with delta of n, this thing would be the answer. So delta of n minus 1. Then this thing convolved with this. What would be the answer? Guys, anybody in the comment section? Sir, if I treat this as x of n, and then this is my wife, she is telling that you have to go at n minus 1. So here the time would be replaced as n minus 1. So can I say here, if I replaced n as n minus 1, I land up at n minus 1, that is delta of n minus 2. Similarly, this thing convolved with this is the resultant output, therefore delta of n plus 1. This thing convolved with this thing, again, if you treat this as husband, this thing as wife is saying you have to go at n minus 1. So replace n with n minus 1. So n minus 1 plus 1, the resultant is n, therefore the output is at delta of n. So this is the concept of husband and wife in the delta function. So this is method 2. In time domain you can solve, or if you want to go into the frequency domain, use the Z transform and get the answer. Okay, let us move forward for the next question then. Next question in front of your screen, check it out. Question number 2. Okay, this is one of my favorite. I usually tell in every class, this is the most expected concept, a classification of system. So the question is, if the input x of t, output y of t of a system are related as y of t is equal to maximum of 0, x of t, then the system is non-linear, time variant, linear, time variant, linear, time invariant, non-linear, time invariant. So two concept, check whether it is linear, non-linear, time variant, invariant. Now your signal is kind of interesting. So interpreting this signal is important. If you cannot interpret this signal, then getting the answer would be tough. 1 minute I will give, I won't give more time, because this signal is not that tough. This question is, I will say, level 1 question. So in signal and system electrical 2021, only few questions were kind of higher level, only few. Majority questions were easy. Okay, so the time is up. Anybody in the comment section? or you are waiting for my answer? Sir, you only give multiple methods, you only tell me tricks and techniques. From your PYQ solution, I will try to learn the concepts. Check it out. First of all, we'll say that the given signal y of t, continuous time domain signal, it is equal to maximum of 0 comma x of t. What does this mean? Among these two values, whoever is maximum, that would be the output. Okay, so let us plot this graph to give you more clarity. If you want to open like this, mathematically speaking, you can do that also, and if you want to plot the graph, you can do that also. Okay, so let us first mathematically see that when x of t is greater than 0, like x of t is 1, 2, 3, 4, it can be anything, right? Suppose it is 1, then 0 comma 1, who is maximum among them? Sir, 1 is the maximum, therefore y of t is 1. Suppose x of t is now 125, so 0 comma 125, who is maximum? Sir, x of t is maximum. So what is the output? Y of t would be 125. So therefore, can I say in this domain always the output is x of t only, because that is the maximum among these two? Yes, sir ji. Suppose I have x of t is less than 0, negative values like -5, then sir 0 comma -5, maximum is 0. Don't say -5, maximum is 0. I hope you understand the timeline. Okay, from minus infinity to plus infinity, that is how we are increasing. So -5 is lower and 0 is higher, so maximum is 0, and if maximum is 0, y would be 0. And suppose x of t is -1, still answer is 0, -2, still answer is maximum 0. So can I say that in this domain always the maximum answer is 0? Absolutely, Sarji. When x of t is less than 0, the output is 0. So plotting the graph is simple now. As you can see, this is our, you can say, input x of t, and this is the output y of t. If I try to plot them, this is x of t, this is y of t, then Sarji, when t is 0, when x of t is 0, 0 comma 0, the answer is 0. So at this point, the output is 0. But on the higher side, x of t greater than 0, the output is linear. Output is a linear graph. Okay. When x of t is less than 0, in the negative side, the output is, sir, anda, 0, flat line. Some students are see, Sarji, the graph is a non-linear graph, therefore the answer is non-linear. No. In classification of system, this logics are not set. Otherwise, you will say, sir, if we have y is equal to sine of 2 pi t, can I say it as a non-linear system or something like that? तो आप ऐसे कहना start कर दोगे. So please be aware. Please be aware. Here what we say is we have to check the additive property. Okay. So what we will do here is x1 of t. If my input is -1, so where input is -1? Here, check it out. Then what is the respective output? y1 of t, sir, the output is 0. Suppose I have one more input, x2 of t at 1. Then what is the output? y2 of t. Sir, when you are at 1, the output is 1 again. Okay, so y2 of t is 1. Now, if I tell you, then what is the addition of them? Let us say y dash of t is addition of the above input, y1 of t plus y2 of t. So 0 plus 1, the answer is 1. Okay. Now check y double dash of t. Now what is y double dash? It is not the double derivative. It is the output when the input is x1 of t plus x2 of t. Okay. So let me now copy this to the next slide, and let me ask you guys, if my input is x1 of t plus x2 of t, what do you feel? What is the output? Tell me in the comment section. x1 of t plus x2 of t. Sir, if you do this calculation, check it out, -1 plus 1, the input, -1 plus 1, the input is 0. If my input is 0, then what is my output? Y double dash of t is equal to 0, because when my input is 0, my output is also 0 from the graph. So finally, I will say that these two outputs are not equal. Y dash of t, y double dash of t, they are not equal, and because they are not equal, they are non-linear. Very simple. Only 4-step process. First step, second step, third step, fourth step. Only 4-step process to get the answer. If y dash of t is not equal to y double dash of t, we are clear that it is a non-linear system. Only by this you can eliminate two options. check it out. You can say that because we are at non-linear, B and C is wrong. Now what about A and D? Who is correct? The right answer is Delhi, because it is time invariant, which is so obvious. If you do not get it, let me copy this, paste it to the next slide, and let us discuss on the time variant invariant concept. In time variant invariant, two-step process. First is delay, second is replace. If I delay whom? Delay input. Okay, so if I delay input, let us say my output is y1 of t. If I delay input by k units, so can I say x of t minus k? 0. Wherever input is there, replace by k units. Wherever input is there, replace by, it is delayed as k units. Okay, so you can see our input is delayed by k units. The next step is replacement of t to t minus k everywhere. So the respective output, let us say y2 of t. If I replace a t, wherever t is there, check it out, t is there, here, 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 wherever t is there, replace t by t minus k. Okay, so in the next steps, replace, again I am getting the same answer. If I copy this, you won't feel sad. Okay, let me see. If I copy this above, is it okay for you guys? Check it out. Wherever t was there, t minus k, t was there, t minus k. Yes, sir ji. This means y1 of t and y2 of t are same. If y1 of t is equal to y2 of t, then happily we can say this is time invariant. If time invariant and we have non-linear, which option is correct? Non-linear and time invariant, Delhi is absolutely correct. So let us move forward for the third question then. So the third question in front of a screen, check it out. Now the question is a little bit tricky. I will say a level 2 question. The causal signal with Z transform, Z square into Z minus A the whole power minus 2 is what? U of n is the unit step signal that we know. So tell me guys, A, B, C or D, which option is correct? Now by seeing this question, you might be thinking, sir, is it inverse Laplace? Sorry, I always see Z transform and I say Laplace. Pardon. Sir, is it inverse Z transform concept? You can think of that. But sir, inverse Z transform is not that easy for this signal. That is also true. So do you have any other method? Sir, what if I try to think in a tangible way that I know if I have a time domain signal as a to the power n u of n, the Z transform is Z by Z minus A. Now, if I do some kind of operation, then this version can be gotten. So what can be the operations? Think on that. Okay. This is also giving you a hint that a to the power n u of n, it is common everywhere, right? So a to the power n u of n, Z transform is Z by Z minus A. Do the operation, try to convert in this version, then you will get your time domain signal and you will get your final answer. So the time is up. Now it's my time to solve this question. You should always know how to get hint from the question. So now when I saw the question, so yes, we are live. Good morning everyone. Welcome to previous year paper solution class. So in the today's class, we are going to see Telecom Gate 2020 PYQs of Signal and System subject. Let us start with the very first question. So the first question in front of a screen, check it out. The transfer function of a stable discrete time LTI system is h of z, that is equal to k times z minus alpha upon z plus 0.5, where k and alpha are real numbers. The value of alpha rounded off to one decimal place with mod alpha should be greater than 1, for which the magnitude response of the system is constant over all frequencies is dash. So this is NAT 2 marker question. Try it out. Your time starts now. So the question is not that tough, because they are giving us one hint. What is the hint? That the magnitude response of this system is constant over all the frequencies. What does this mean? Sir, this means all pass filter. Yes, we have all pass filter. So is there any property in all pass filter? See, in Laplace transform you have studied one property, that is pole zeros are mirror of each other about the j omega axis. But that was in the Laplace transform. But here we have Z transform. So the scenario is different. So the property would be little bit different. But there is again some relationship between poles and zeros. But what is that relationship? Check it out. Okay, last 15 seconds to go. This is just a 1 minute question. Even if you know the property, it's 30-second question in the exam. Okay, so finally 8 seconds. 7, 6, 5, 4, 3, 2, 1. Done. Okay, so now it's my turn to solve this question. Check it out. The first point is, they are giving us the magnitude response of the system is constant over all frequencies, which means it is all pass filter. In short, also known as APF, all pass filter. So in the all pass filter, in the discrete time domain, we have a property. So what is the property? Digital all pass filter have conjugate reciprocal pole zero pair. So what does this mean? It simply means if you have 0 represented as z, but let me write it here completely only. If you have 0 represented as z, that is equal to 1 upon, reciprocal means 1 upon. Then we have conjugate pair. Conjugate pair means pole conjugate. Star means conjugate. Okay, so I hope now it's very clear. If you check the question, what is pole and what is 0? Sir, to get the pole denominator equal to 0, to get the zeros numerator equal to 0. Okay, so if I do that, I will get my poles and zeros. So as per the question, h of z was given as k times z minus alpha divided by z plus 0.5. So to get the pole denominator equated to 0, therefore z is equal to minus 0.5. To get the 0, numerator is equated to 0. So z minus alpha, that is equal to 0. You get your zeros as z is equal to alpha. Okay, so this is your pole, this is your 0. Now you know the relationship. The relationship is 0 is equal to 1 upon pole conjugate. So if I use that, then I can say, by using this concept, I can say now that my 0 is alpha, that is equal to 1 upon conjugate of this. So this is a real number, so conjugate of a real number is real number only. So minus 1 upon, or let me write in this way, 1 upon minus 0.5, which is nothing but 1 upon minus half, that is equal to minus 2. Now alpha is equal to minus 2, that is the correct answer. But you will say, sir, they were saying that mod alpha should be greater than 1. They are just saying mod alpha should be greater than 1. They are not asking you about the mod value of alpha. They are just saying that if you have alpha, then if you take the mod of that, the value should be greater than 1, which is happening in our case. So a lot of students thought they were asking us the magnitude of alpha. No. They are not asking the mod of the alpha. They are just saying if you have found the alpha, then check. If I take the mod of alpha, so mod of -2, that is equal to 2. Is it greater than 1? If it is greater than 1, then yes, it is absolutely correct answer. Therefore, this is the answer. Okay, so the answer is -2. Let us move forward for the next question. So the next question is coming in front of your screen. Check it out. One more good question, but this question requires 2 slides. Okay, so read this slide. Which one of the following pole 0 corresponds to the transfer function of an LTI system characterized by the input-output difference equation given below? So please write it down. This is the difference equation. Y of n, that is equal to summation k is going from 0 to 3 minus 1 to the power k into x of n minus k. Now once you have seen this, do the Z transformation, get the poles zeros and tell me which option is correct. Okay, so see it here. You will get how many terms? K is 0 first term, k is 1, k is 2, k is 3. 4 terms you will get, and then you have to comment on which of the following pole 0 plot is correct. The first option is saying at the origin there is a third order pole, which means the pole is having the values 0, 0, 0. 3 times that value is repeating. Similarly, here also 0, 0, 0, here also third order, but here fourth order. Then talking about the zeros, which is represented by circles. So in the option A, they are saying at 1, okay, so let me say in this way, 1, j, minus j. These are the zeros. Here, -1, j, minus j, these are the zeros. Here in between, like you can say that first quadrant on the unit circle, we have a 0. And then -1, we have a 0. And here in the fourth quadrant, we have a 0. And here they are saying we have 1, 2, 3, 4. 4 zeros we have. So A, B, C looks familiar, like 3 poles, 3 zeros. D is kind of very different. 4 poles, 4 zeros. So you have to think on that. The time is up. The time is up. Now it's my time to solve the question. So first of all, we will open this. So let me copy. Let me say that the given difference equation is y of n, that is equal to summation k is going from 0 to 3 minus 1 to the power k, then x of n minus k. Correct? So now if k is 0, then we have -1 to the power 0, which is 1. And here if I substitute k is 0, then x of n is the output. Then k is 1. So -1 to the power 1, negation. Okay, so negation. Here k is 1, so x of n minus 1. Then k is 2. So if k is 2, then -1 to the power even is +1, and here k is 2 will give you the output x of n minus 2. If you substitute 3 instead of k, then check it out. -1 to the power odd, the answer is -1. Therefore, we have to say minus outside, then x of n minus 3. Done. This is my y of n. Now comes the concept. What is the concept, Sirji? The concept is very simple. In the Z transform, x of n has the Z transform capital X of Z. But if the time is shifted, let us say n minus a, then the Z transform says because the time is shifted, raise that to the power of, or not e here because Laplace nahi hai, raise to the power of Z. So Z to the power minus a, then into capital X of Z. Okay, so now check it out. The same scenario is happening here. Therefore, if I take the Z transform, check it out. If I take the Z transform, can I say y of n Z transform would be y of z, that is equal to x of n Z transform is x of z minus whatever is here raised to the power of z, so z to the power minus 1 x of z. Similarly for the next z to the power minus 2 x of z, next minus z to the power minus 3 x of z. Okay, therefore the transfer function that is equal to output by input looks like what it looks like. Sir, check it out. Here if I take x of z common, then 1 minus z to the power minus 1 plus z to the power minus 2 minus z to the power minus 3, this is remaining. Now if you see carefully, can I say numerator if I multiply with z to the power 3, denominator also we have to multiply with z to the power 3, and if I do that I will get a proper positive version of this transfer function. So therefore my transfer function, which is represented as capital H of z, it looks like z cube minus z square plus z minus 1 upon z cube. Now a lot of students have problem in identifying the zeros. Sir, check it out, a cubic equation, how to get the values of zeros? Anybody in the comment section? What is the values of zeros? See, pole version is very simple. If I need the pole denominator equal to 0, z cube equal to 0, z is 0, 0, 0, third order. So pole part is simple. What about zeros? Anybody? Check it out here. Pole can be said as z cube equal to 0, which means z is equal to 0, 0, 0. Okay, talking about the zeros, then if z cube minus z square plus z minus 1 is equated to 0, here if I take a z common, then z square minus 1, okay. So let me take a z square common. What will happen? Z minus 1. Sir, here also we have z minus 1. Now is it easy? Common factors, z minus 1 taken outside, the uncommons are inside, and now you will say this is equated to 0 and then this is equated to 0. Okay, so when z minus 1 equated to 0, z is equal to 1. When z square plus 1 is equated to 0, z square is equal to minus 1, which indicates z is equal to plus minus root minus 1, which is plus minus iota. Agreed? Then do let me know in the comment section. Yes. So we have third order pole at origin. This is third order pole, okay, at origin. And then we have 3 zeros. First at plus I, next at minus I, and finally at 1. So if you check now the options, you will say, sir, C zeros plus I, minus I, plus 1, and third order pole. Absolutely correct. Option A is correct. Option D is wrong because fourth order we do not have. Option B is wrong because we do not have 0 at minus 1. Similarly, C is wrong because we do not have 0 at minus 1. Agreed? Then do let me know in the comment section yes, so that we can move forward for the next question. So this was the second question of the day, and I guess this question is also easy, but now slowly you will see the toughness in the telecom 2020 paper. Let us see the third question, one of the good question. The output y of n of a discrete time system for an input x of n is given like this. Okay. The unit impulse response of the system is what? Option A 0 for all n, B is saying 1 for all n, C is saying unit step signal u of n, and D is saying unit impulse signal delta of n. So I will give you exactly 1 minute to solve this question. There is a trap in this question. I have seen a lot of students marking the options incorrectly because they are solving this in hurry. So you do not solve this in hurry. You take your time, you think, you solve. Okay, last 30 seconds to go. Sir, I am not able to understand what the examiner is asking. They are just asking the unit impulse response. They are asking you the output. But sir, what is unit impulse response? When you give the unit impulse input, then you get the unit impulse response. So this is indirect hint for the input data. This is indirect hint that x of n you have to treat as delta of n, unit impulse input. Okay, so that was the concept. Then comes the calculation. So let me write the concept first. This is your LTI system, linear time invariant system. You are giving input to this system. And what is the input? Sir, the input here is unit impulse input. Okay, so unit impulse input if you give, definitely you will get output which would behave as unit impulse response. Okay, so now check it out. When I say unit impulse input, this means x of n, because this was a discrete version, so x of n, that is equal to delta of n. Okay, unit means the magnitude, the amplitude here is 1, so unit, and then impulse, you know it very well, chronicle delta function. Okay, so now if I give x of n is equal to delta of n, what do you feel? What would be y of n? Sir, y of n is equal to maximum minus infinity less than equal to k less than equal to n mod of, instead of x of k, substitute delta of k. And then now tell me, what is the output matching with? Is it 0 for all n? Is it 1 for all l? Or else it is a special function, u of n or delta of n. Check it out. So to understand that, we'll say now, therefore, y of n is equal to maximum from minus infinity less than equal to k less than equal to n mod of x of k, and because we are saying that x of n is equal to delta of n, substitute here, it would be delta of k now. So maximum minus infinity less than equal to k less than equal to n, then we have delta of k. Okay, now let us focus on the calculation. This calculation can be understood more clearly by drawing the graph. Those students who are smart, they will say, sir, how slow you are solving, we have solved in seconds. But those students who require the clear understanding, उनका साबुन थोड़ा सा slow है. For those students, check it out. Delta of n nature. Delta of n works at n equal to 0 only. And what is the value? The amplitude is 1. What about the other stuff? When n is 1, the amplitude is 0. When n is 2, the amplitude is 0. When n is 3, amplitude is 0. Backward also, amplitude is 0. Backward also. Okay. So as you can see, in only at n is equal to 0, the amplitude is 1. Otherwise, the function is 0. When I say for n is less than 0, what will happen to this thing? Sir, you are asking for the negative values of n. So for negative values of n, y of n is equal to maximum value from k is going from minus infinity to the negative values, n is less than 0, and then we have delta of k. But sir, if I see the samples of delta of k in the negative version when n is less than 0, everyone in the comment section, what are the samples of the delta function in the negative side? Sir, all of them are 0. Yes, all of them are 0. Then what would be the maximum? Sir, maximum, all of them are 0. The maximum value would be 0. Yes or no? So here we have to say that delta of k is 0 always in this range. Okay, so here we have to say, let me write in this way, otherwise you will say, sir, delta of k is 0. ये देखो यहाँ पर n equal to 0 पर तो 1 है. When I saying delta of k is 0 always in this range, in n less than 0 range. Okay, therefore y of n is 0 in n less than 0. Okay, so let me take this calculation to the next slide, and this part is clear. When I am trying to draw the plot of y of n, if this is n, this is the amplitude of y of n, it is very much clear now by the calculation. If this is n is 0, the negative version n is minus 1, n is minus 2, n is minus 3, dot, everywhere the amplitude is 0. What about at n is equal to 0? What is the behavior when I say for n is equal to 0? Then sir ji, this would be y of 0, that is equal to maximum minus infinity less than equal to k less than equal to 0, and then a delta of k mod. Now you will say, sir, check it out, once you are changing the range, now you are saying the range is from 0 to minus infinity. In all these samples, take the maximum value of the sample. So the maximum value occurs, check it out, at n is equal to 0, we have 1 as the output. Other samples, other outputs are 0, right? So 0 and 1, who is maximum? Maximum is 1. Therefore, what is the answer when n is 0? Sir, when n is 0, y of 0 is equal to delta of 0 as the maximum from this sample, delta of 0, that is equal to 1. Okay, so exactly at n is equal to 0, this y of n is now 1. What about at n is 1? n is 2, and so on and so forth. Now you will say, sir, for n is equal to 1, y of 1 is equal to maximum k is greater than equal to minus infinity less than equal to n, but n is 1, so let me write it here, 1, then mod delta of k. Again you will say, sir, go back and check. When you are saying that the range of n is from 1 to minus infinity, among all these samples, choose the maximum, then maximum is at n equal to 0, 1, we have maximum. Wait a second, I guess I am back again. Yes. So what I was saying is, I was simply saying that when you are saying the range is from 1 to minus infinity, and when I am checking this from n is 1 to minus infinity, what is the maximum value? Sir, at n is equal to 0, we have 1, and that is the only maximum. Therefore, I am saying in this range, again, the delta function is giving me the maximum output as 1. So, y of 1 is again 1. So, draw that in the graph. Y of 1 is again 1. What about y of 2? Now, you know it very well, sir. Y of 2 is again 1. And therefore, if you try to plot this, this would be 1, 1, 1, 1, 1. And this is the nature of what? Sir, this is the nature of u of n. Yes or no? If I copy this graph to the next slide, and if I ask you guys, isn't this the nature of u of n? What is y of n behaving as? Y of n is behaving as 1 when n is greater than equal to 0. It is 0 for n is less than 0. Therefore, y of n is u of n. This is the answer. Understood? Then do let me know in the comment section yes. Just for those students who are thinking, sir, how come y of 2 is 1? थोड़ा सा कैलकुलेशन मैं आपको दे देता हूँ ताकि आपको भी थोड़ी सी तसल्ली हो जाए. How come y of 2 is 1? Check it out. जगह कम है ना, बाकी कुछ नहीं, हमको देने में कोई हर्जा नहीं है, जगह हमको कम पड़ जाती है ना स्लाइड्स में, और इतना डिटेलिंग एक्सप्लेनेशन इसलिए दे रहा हूँ सो दैट यू डू नॉट हैव एनी डाउट्स आफ्टर द क्लास. ओके, चेक इट आउट. व्हेन n is equal to 2, y of 2, what will happen to the range? Sir, when n is equal to 2, y of 2 would be maximum k is greater than equal to minus infinity less than equal to 2. Again in that range, n is 2 up till minus infinity. In all these samples, what is the maximum value of delta? Sir, the maximum value is 1. At n is equal to 0, we have 1. So the maximum value is 1. And if the maximum value is 1, now you are very much happy that in all the positive sides, we'll get the output as 1, 1, 1, 1, 1. So it will behave as a unit step function. Therefore, the correct answer is now option C, unit step function. So one of the good question analysis in the graph to get the answer. So let us move forward for the next question now. Check it out guys, the next question in front of your screen is very much dangerous because a lot of calculation is involved. हाँ, डरा दो सर जी, पहली सब कुछ नहीं, मैं जो है वो बता रहा हूँ. So yes, so we are live. Good evening everyone. Welcome to previous year paper solution class. So in the today's class, we are going to solve Telecom Gate 2019 PYQs of signal and system. Let us start with the very first question. So the first question in front of your screen. Consider the signal f of t that is equal to 1 plus 2 cos of pi t plus 3 sine of 2 pi t by 3 plus 4 cos of pi t by 2 plus pi by 4, where t is in seconds. Its fundamental time period in seconds is dash. Now this is NAT question, but not that tough question. It's easy question. Fundamental time period. Sir, we have three sinusoid terms. Here cos, here sine, here cos. So what is the value of omega 1, omega 2, omega 3? Sir, omega 1, check it out, cos of omega 1 t, so omega 1 is pi, sine of omega 2 t, so omega 2 is 2 pi by 3, cos of omega 3 t plus phi, so omega 3 is pi by 2. Once you get omega 1, omega 2, omega 3, I guess finding the fundamental time period is not that tough. Okay, I was about to give you only 45 seconds because this can be solved pretty fast. Save the time from this easy question, invest in the hard questions, because in the today's class you will see absolutely hard questions from the signal and system. Okay, so let us see the solution. First point was about omega 1 is equal to pi. So what is the respective fundamental time period? That is equal to 2 pi divided by omega 1. So that is equal to 2 pi divided by pi. So T1 is equal to 2. Now omega 2, that is equal to, from the question it was 2 pi by 3 by comparison. So T2 is equal to 2 pi divided by omega 2. So 2 pi divided by omega 2 is 2 pi by 3, 2 pi getting cancelled, 3 is left. Talking about omega 3, that is equal to pi by 2. So now T3, that is equal to 2 pi divided by omega 3. So 2 pi divided by omega 3 is pi by 2, sir ji, pi getting cancelled, 4 is left. Okay, so now check it out. We have to say that since T1, T2, T3 is found, but we need the fundamental time period of f of t, and that is the collection of all these terms. So therefore, the final fundamental time period is equal to LCM of T1, T2, T3. So that is equal to LCM of 2, 3, 4. Now 2, 3, 4, if you do not know how to find LCM, let me teach you. Very easy. 2, 3, 4, common term 2. So 2 1s are here, nothing common, right as it is. Here 2 2s are. Now nothing common. So in the right angle fashion, multiply all the terms. You will get your LCM. So 2 into 1 into 3 into 2. Sir, the answer is 4 into 3, 12. Therefore, the answer of the LCM is 12. Okay. Very simple. So yes, this is method 1 to solve this question. I won't recommend this method because I feel this method is little bit lengthy, because you can solve the same question with the help of the HCF concept. Because omega 1, omega 2, omega 3 is known, so the final signal f of t will have the fundamental frequency omega, that is equal to HCF of omega 1, omega 2, omega 3. Okay, so now HCF of what term? Sir, we have fractions. Check it out, pi, 2 pi by 3, and then pi by 2. If you have fractions, then do not worry. Then it is HCF of numerator, so pi, 2 pi pi, and LCM of denominator, so 1, 3, 2. Okay, so now let me shift this to the upper slide, and now let me ask you, therefore, what is the final fundamental frequency? Sir, highest common factor between these three terms, it is pi. LCM of 1, 2, 3, it is 6. Okay, so you got the fundamental frequency, but they were asking about the fundamental time period. So now method 2 says fundamental time period can be found. If omega is equal to pi by 6, then t is equal to 2 pi by omega. So that is equal to 2 pi by 6. Pi getting cancelled, 2 into 6, yes, the answer is 12. Done and dusted. So this is how you can get the answer fast, or otherwise you can follow this approach also. We have two methods to solve this question. Let us move forward for the next question. So the next question in front of the screen, check it out. Okay, so from Z transform we have this question. GATE 2019 telecommunication, it is MCQ question. First, write down the important points. Let h of z be the Z transform of a real valued discrete time signal h of n. Very important, real valued. Why, Sarji? Because further they are saying if p of z is equal to h of z into h of 1 by z has a 0 at this position. Now this nature of this 0 is a complex. When you have real valued signals, then the zeros are 0, or you may say real or complex conjugate complex pairs. So if we have complex number, then they should exist in the conjugate pairs. That is the reason I told you real valued, very important note. And then they are saying that P of Z has a total of 4 zeros. Which of the following plots represents all the zeros correctly? So now finally you have to comment on which plot is giving me the answer, A, B, C or D. Okay, so final 30 seconds. As you can see, inside the unit circles 2, right, and then outside 2 like this, or else outside 2 like this, outside 2 again. You can see they are close to the unit circle. This were away from 1, these are at the position 1 1, right, and these are inside the unit circle. So A, B, C or D, which one is correct? So the time is up. Now it's my time to solve the question. As I told you, the important statements, I am going to use those statements to get the answer. The first point is P of Z. They are asking the plot of P of Z. P of Z is made from H of Z and H of 1 by Z. So basically zeros of P of Z is equal to, if you need zeros of this term, this is equal to zeros of this term, right or wrong? Yes, sir ji. So zeros of P of Z is basically equal to zeros of H of Z and H of 1 by Z. Now my task is to find the zeros of these pairs. How to get that? To get that, you have to check about the H of n nature. They were saying H of n is real valued signal. So when we have real valued signal, then the zeros and poles both are real or complex conjugate pairs, right? So now here we will say that therefore, since we had the complex given in the data, so they should exist in the complex conjugate. So zeros are complex conjugate pair. Okay, so now finally I will say that if H of Z has zeros Z1 as given in the data, then Z1 star should also exist. Similarly, H of 1 by Z, like in the above, if Z is the term, Z1 is the 0. So 1 by Z is the term, then 1 by Z1 is the 0 and its conjugate pair 1 by Z1 conjugate. These are the zeros of this term. So finally I will say that in the question they are giving us there is a 0 at half plus half j. So I will say, as per the given data, okay, if you need the zeros of P of Z, there are in total 4 zeros. The first 0 is at half plus j by 2. This was given. This is given. Now as per our concept, Z1 star is also a 0. Right, and 1 by Z1 is also 0, 1 by Z1 star is also 0. So now 3 zeros we will find by using the simple concept of conjugate. Conjugate means the imaginary part change its sign, real part doesn't change its sign. 1 upon Z1 is equal to 1 upon half plus j by 2. So multiplying with the rationalized term, half minus j by 2, here half minus j by 2. Now this is like a plus b into a minus b, which is a square minus b square. Numerator part is half minus j by 2, denominator is like a square minus b square. So half square is 4 and then minus j by 2 the whole square. Please check it out. This is minus j square by 4. J square is iota, right? Like j is iota. So j square would be negative 1. If j square is negative 1, outside we have negative, overall numerator is positive 1 and denominator is 4. So finally I will say here we have positive 1 by 4. Okay, so now solving this is half is getting cancelled from numerator and denominator everywhere, and we are getting 1 minus j as the answer. Okay, so therefore if 1 by Z1 is 1 minus j, 1 by Z1 conjugate would be what? Sir, imaginary part will change its sign. So 1 plus j is the answer. So we got the 4 zeros. 1, 2, 3, 4. We got the 4 zeros, and therefore if you try to plot this, what are the positions you will get? Let me draw the z plane. This is the real axis, real of z. This is the imaginary of z. Then we have unit circle which is mod z, that is equal to 1. So this is the position of j, right? So this is j, this is minus j, this is real 1, this is minus 1. If I check my zeros, then we have half comma half, right? In the real part half, in the imaginary part half. So half comma half is somewhere here. 0 is represented like this, okay? This is half comma half. And then we have one more term, half comma minus half. So half comma minus half in the real half, in imaginary minus half. So this is the position, right? Then we have one more 0 which is at 1 minus j, which is 1 comma minus 1. In real we have 1, in the imaginary minus 1, which means j, right? So this is the position. And then 1 minus a j, this is the position, right? This is the position. So this is our answer. Now exactly this shape we can see in Delhi. So Delhi is the correct answer. Other options are wrong. Check it out. So basically here we do not have 1 plus j. So therefore this is wrong. Here we do not have this, okay, in our answer we do not have this as the 0 because minus 2 was not there. So it's wrong. Here if you see, they are saying 2 plus 2j. We have 0 at this position. No, we do not have. We have 0 at 1 plus j as per our calculation. Check it out. Okay. So yes, finally we had Delhi as the correct answer, and I guess this is also easy. Two concepts you have to understand. P of z is related with this term, so we have to focus on this term. Therefore we focused on h of n. It was real, so zeros are complex conjugate pair, and then it was easy to get the answer. Now moving forward for the next question, not all the questions are that much easy because now you will see toughness in the problems. See how the big problem is. 2009 telecommunication, your time starts now. It is desired to find a 3-tap causal filter which gives a 0 signal as an output to an input of the form x of n, that is equal to c1 e to the power minus j pi n by 2 plus c2 e to the power j pi n by 2, where c1 and c2 are arbitrary real numbers. This desired 3-tap filter is given by h of 0 that is equal to 1, h of 1 that is equal to a, h of 2 that is equal to b, and h of n that is equal to 0 for n is less than 0 or n is greater than 2. Okay. What are the values of the filter taps a and b if the output is y of n that is equal to 0 for all n, where x of n is as given above, but here we have below as the structure. So you can see the structure. The structure is x of n is the input, y of n is 0 always. Now this h of n is like this. At n is equal to 0 it is 1, at n is equal to 1 it is a, so on and so forth. So what do you feel? When will be our output 0? What should be the values of a and b such that always you get y of n 0? Okay, so the time is up. Let us see the solution now. First point to note down is, a lot of students after seeing this question, what comes in their head? Convolution. Sir, input is given, h of n is given, output is 0. Sir, convolution formula will use to get the answer. Correct, but it is time taking method. I'm not saying that it is wrong, it is method 1 to solve the question, but then we have a faster approach as well. So method 1 I know that you are solving, but now let us see the method 2. So in the method 2, the concept is, please write it down because a lot of students do not study the concepts properly. This is the system. We are giving input x of n, we are getting output y of n, and here we have h of n. So basically you are saying that h of n, Sirji, it's a time domain signal, x of n time domain, y of n time domain. Therefore y of n is equal to x of n convert with h of n, and so on and so forth. But what I am telling here is, in the method 2, h of n is a time domain signal, but its Fourier transform would be a frequency domain signal, and it would look like a capital H of e to the power j omega. Our input is also of this format, complex exponential format, which is, let us say, e to the power j omega naught n, a specific frequency. As per our question, we can see here what is omega naught, minus pi by 2. Here what is omega naught, pi by 2, right? So specific frequency. So now when input is passed to the system, what we get as the output now is, concept says this is x of n into, yes, you are seeing correctly, because this is time domain but this is frequency domain. So x of n into capital H of e to the power j omega is changed to omega naught. This is the concept. By this concept, you can solve this question pretty fast, because now the question says we want output always 0. If you want y of n 0, if you need y of n is equal to 0, therefore this implies this thing should be equal to 0. Okay, h of n into capital H of e to the power j omega naught should be equal to 0. Now check it out carefully, that x of n is the input, which is not 0 obviously, but this capital H of e to the power j omega naught, it is made from two things, magnitude and phase, right? So I will write in this way, x of n into magnitude is mod h of e to the power j omega naught, and the phase is, let us say, e to the power j theta. Okay, so phase into magnitude. And now if I ask you, how will be LHS equal to RHS? To make sure that LHS is RHS, this thing we know that they are not equal to 0, complex exponential pairs, they are not equal to 0. So obviously this thing should be equal to 0, because this thing will be some constant a. If this thing is 0, then a into 0, then we can say the answer is 0, correct? So these are the complex exponential which cannot be 0, and this can be made 0. So now our focus is to make the magnitude of h of e to the power j omega naught 0. I hope you understood the concept. Very simple concept. Okay, so now let us move forward for the steps. The first step is h of n, that is given as 1ab, where this is the origin. At n is equal to 0, h of n is 1. So if I use the z transform, using the z transform, I can say h of z is equal to Welcome to previous year paper solution class. In the today's class, we are going to solve Telecom GATE 2018 signal and system PYQs. So let us see the very first question. The first question in front of your screen. Let x of k is equal to k plus 1, where k is greater than equal to 0, less than equal to 7, be 8-point DFT of sequence x of n, where x of k is equal to summation n is equal to 0 to n minus 1, x of n into e to the power minus j 2 pi n k by n. The value correct to two decimal places of summation n is equal to 0 to 3, x of 2n is dash. Now this question is a little bit interesting because DFT signal is given, time domain signal is not given, and what they are asking us is about time domain signal only. So which concept you are going to use? Sir, DFT is given, time domain signal is asked. IDFT concept? Yes, inverse DFT concept will help you to get the answer. So I will give you exactly 1 minute 30 seconds to solve this question. Think, calculate, use formula, simplify, get the answer. 4 terms you need. Which are the 4 terms? So do the expansion of this function, you will get those 4 terms. X of 0, x of 2, x of 4, x of 6. Get those 4 terms, solve, get the answer. Last 15 seconds to go. Telecom paper questions are actually good questions. You will get little bit level up questions. So 5, 4, 3, 2, 1, done. So the time is up. Now it's my time to solve this NAT question. Let us see the solution. So the first point is inverse DFT concept says use capital X of k because it is given and find time domain signal small x of n using the formula of IDFT. And in our question what we need is summation n is equal to 0 to 3 small x of 2n, correct? So when n is 0, this signal becomes x of 0. When n is 1, this signal becomes x of 2. Similarly, when n is 2, signal becomes x of 4. When n is 3, signal becomes x of 6. Now you need these 4 terms to get the answer. And I know a lot of students have got this 4 terms using the IDFT concept, and they were saying, sir, this question is very lengthy, it cannot be solved in 1 minute 30 seconds. Yes, because this is method 1. If you are using this kind of standard solution, standard method to get the answer, and it will take surely 2 minute 30 seconds or more than that, then what to do, Sarji? There is another way to solve this question. And you might be thinking, what can be the another way? Method 2 is a tricky way to get this terms, because at the end if you need the answer of this function you need these 4 terms, and if you need these 4 terms, one of the way was IDFT, the other way is a tricky way. The tricky way is, since in the question one formula was given, what was the formula? The formula we use in DFT is capital X of k is equal to summation n is going from 0 to n minus 1 small x of n into e to the power minus j 2 pi k small n by capital N. Capital N here is 8 because 8 point DFT is used. Now check it out. If I substitute k is 0 in this formula, what will happen? Sir, if you substitute k is 0 in the formula, then capital X of 0 is now equal to summation n is going from 0 to capital N is 8, so 8 minus 1 becomes a 7, then small x of n, since k is 0, e to the power 0 becomes 1, correct? So finally I can say this is my resultant. Check it out. Do you know all these players? If I do the expansion, do you know when n is 0 what is small x of 0? No, Sarji, we do not know. Similarly, if I substitute n is 1, do you know this signal? No. Let us do the expansion. What happens here? Sir, x of 4, x of 5, x of 6, and finally x of 7. Hush. Correct? X of 7. Now check it out. Your requirement is 0 plus x of 2 plus x of 4, x of 6. And here you are getting x of 0 plus x of 1 and so on and so forth. You might be thinking, sir, I need only 4 terms. What is the use of getting all these 8 terms? The point is, now substitute k is equal to 4 again in this formula and see the magic. If I substitute k is equal to 4, then capital X of 4 is equal to summation n is going from 0 to 7 x of n into here. When k is substituted 4 and capital N is 8, this 4 into 2 8, this 8 gone, e to the power minus j pi n left, which is nothing but minus 1 to the power n, correct? Which is minus 1 to the power n. Now do the expansion and see the magic. Let me copy this part to the next slide and see the magic. If I do the expansion, when n is 0, what will happen to this signal? Sir, when n is 0, this is 1, this is x of 0. Okay. When n is 1, this thing is x of 1, this thing is negative 1. Because this is negative 1, this positive would be changed to negative. Correct? Now, when n is 2, what I will get is x of 2. Here 2 minus 1 to the power e1 positive 1, so this would be a positive signal only. And now you can see the pattern, positive, negative, positive. So next term would be negative, then next term would be positive, next term would be negative, next term would be positive, and finally next term would be negative, correct? If I tell you now, this is my equation 1, This is my equation 2. Now add equation 1 with equation 2. What will happen? Left hand side is the DFT signals which will get added as capital X of 0 plus capital X of 4. Right hand side, if you see carefully, then cancellation will happen surely. X of 1 minus X of 1 gone, or all the odd terms, X of 3 minus X of 3 gone, correct? And all the even terms like X of 0, X of 2, they would be twice, while addition, see, 2 times X of 2. And all the odd players, X of 5 minus X of 5, they would be vanished. If that is the case, can I say my resultant answer would be twice of all the even players, X of 0 plus X of 2 plus X of 4 plus X of 6? If yes, don't you feel this is what I needed? Go back and check. What was my requirement? My requirement was this function, which is this player. This player similar. Yes, let us rearrange and let us comment now. Therefore, if I rearrange X of 0 plus X of 2 plus X of 4 plus X of 6 is actually equal to this stuff, capital X of 0 plus capital X of 4 divide by 2, correct? This 2 will go to the denominator, so divide by 2. Now therefore, this thing is nothing but summation n is going from 0 to 3 x of 2n. And what about this player? Sir, this player can be found by the given data. Check it out. What is the given data? Capital X of k is equal to k plus 1. Okay. Capital X of k, since capital X of k is equal to k plus 1, can I say when k is 0, this function becomes 0 plus 1, which is 1. When k is 4, this function is 4 plus 1, which is 5, and then divide by 2. So 6 by 2, the answer is 3. That fast you can get the answer, provided you know this kind of analysis trick. Okay, otherwise you have method 1 to use the IDFT concept to get each and every term and then comment on the answer. But what I did here is I used the DFT formula only. Okay, I used the DFT formula. I substituted k is 0, got my first equation, substituted k is 4, got my second equation, because I know that this is how I know that positive. This is a trick also given in my previous classes. In DFT, the first signal at k is equal to 0, it is always a summation of the given time domain signals. As you can see, summation of all the players. And when you do n by 2, if it was 4 point, then 4 by 2 x of 2, right? Here it is 8 point, so 8 by 2, which is 4, right? So that capital X of 4 will always have the plus minus fashion. X of 0 positive, then negative, positive, negative, positive, negative, in this way. So this is the trick used in the DFT. Almost in all question I try to use this trick. The k0 function all positive, the n by 2 positive, negative. So I use that trick to get the answer. So I hope you understood this first question, very easy question. Now let us see the second question. So the second question in front of the screen. The second question is one of my favorite because based on the basics. A lot of students never study the basics. Check it out. Let the input be u and the output be y of the system, and the other parameters are real constants. Identify which among the following system is a not a linear system. Not a linear. Now first one is kind of a differential equation. So in the engineering mathematics also I have told you 3 steps to identify whether the differential equation is a linear or a non-linear. Same concept you have to use to check here whether it is linear or non-linear. And check it out, your requirement is the system should be a non-linear system. In 4 options, one system would be a non-linear system, and that would be the correct answer. But when I see option A, the coefficients are constants, right? The powers of the derivative is 1, and also this y has power 1, y has power 1, this u has power 1, u has power 1. So the 3 steps which are used in checking linear differential equation, I use that 3 steps again. For those students who do not know the 3 steps, visit the engineering mathematics course. I have explained in the differential equation chapter. So yes, by that 3 step, this is a linear differential equation. So a linear system. So this is not the correct option. Then B, C, D you have to check. and then you have to comment on the answer. But when you see the option Bombay, it seems like convolution. Yes or no? It's a convolution between the two signal, and if you are doing convolution between the two signal, obviously those systems are LTI system. So if it is LTI, this means it's a linear system. Okay, so B is also a linear system. Now C or D, definitely one culprit is there. So you have to check who is the culprit, you will get the answer. Okay, I will give you 15 seconds, check it out. Okay, so the time is up. The right answer is, who is the culprit? Sir, the culprit is Calcutta. Okay, it is not LTI. Now why? Option A, it is a linear differential equation, so linear system. This is nothing but the convolution concept. So convolution always says that it happens in LTI system. Okay, so linear also and time invariant also. Then Calcutta, Delhi, let us focus on Calcutta, option C. If I focus on option C is y is equal to AU plus B. If my input is U1, then what is my output? Y1, that is equal to AU1 plus B. If my input is U2, what is my output? Y2 is equal to AU2 plus B. Okay, so let us see y dash now. Y dash is not the derivative. Y dash is just the summation of y1 plus y2. So if I do the summation of them, A is a constant outside, u1 plus u2, and then b plus b is to b. Okay, if my input is u1 plus u2, what is my output? Let us say y double dash is the output, and when my input is changed as u1 plus u2, I have A times u1 plus u2 plus b, correct? Now if I see y dash and y double dash, are they same? No sir ji, y dash, y double dash, they are not same. As you see here, 2b and b, they are different. Therefore finally y dash is not equal to y double dash. This means it is a non-linear system. Done. Non-linear system, we have got it. So Calcutta is a non-linear system. Actually this question is very simple question, very standard question. There is no need to even solve. Once you see 4 options, this option is a culprit option. Okay, verbally also you can solve in the exam, but being a teacher I have to write each and every step so that I can make you understand why some systems are linear, why some systems are non-linear. If you even check the option Delhi, verbally you can say that y1 output would be AU1 and y2 output would be AU2. Addition of them y dash would be AU1 plus AU2. Y double dash input is changed as U1 plus U2. So A times U1 plus U2. See, both of them are same. If both of them are same, this means that your given system is a linear system. Agreed? So option Delhi was also a linear system. This is how you can prove. So finally non-linear system we got in the option Calcutta. Option Calcutta is done. Let us see the next question. So let us see the third question. So the third question in front of a screen. A band limited low pass signal x of t of bandwidth 5 kHz is sampled at sampling rate fs. The signal x of t is reconstructed using the reconstruction filter h of f, whose magnitude response is shown below, which is like this. The minimum sampling rate fs in kilohertz for perfect reconstruction of x of t is dash. So this question is not that tough, very simple question, can be solved in 1 minute. So last 30 seconds you have. 2-step process. First draw this x of t, then the spectrum of the sampled signal, and then use this filter, reconstruct. While reconstruction, what is the condition? As per the condition you will get the minimum sampling rate fs. Okay, so 5 4 3 2 1, done. Okay, so let us see the solution now. The very first step is, what was the nature of the x of t? It is a band limited low pass signal working from -5 to 5, correct? Now because the spectrum nature is not given, what we are going to do is, let us assume an arbitrary spectrum of x of t, which looks like this. This is our frequency f in kilohertz. This is the magnitude capital X of f frequency spectrum. Let me take a triangular signal working from -5 to 5, 0, low passing signal, right? Now, what we are doing is, this signal is sampled at a sampling rate fs. Now that is the whole point. What should be that sampling rate? This is as the minimum sampling rate for perfect reconstruction of x of t. When I say for a perfect reconstruction of x of t, means there should not be any duplicate image, and such arrangement you have to do. You can get the duplicate image if your sampling rate is not perfect. Therefore the question is very specific: minimum sampling rate fs in kilohertz for perfect reconstruction. And I will explain you diagrammatically also what they are trying to say in this question. If you just know the formula, if you have by hearted the formula, it's a few second question. But if you want to understand this graphically, let us shoot for the second step. Okay, so this is the first step, given signal x of t. The second step is the spectrum of the sampled signal.